Okay, can you hear me? I'm running now. That's good. um, so today we are going to start learning helper. So good evening. Good evening, guys. So let's move into the practical sessions. And before going to that, we'll do some question from the dimension. So last week we practiced dimension, but before moving to this one, let's improve that one again by doing one question. Okay. Otherwise, last week we did only two questions, I think. It's better to do another question. Pick a we'll do a one question. Okay. So this is Vernier Caliper, so I didn't open the things. Yeah, doesn't matter. Okay, let's do one question because I prefer to do a question from that part to make sure that you are capable enough to do whatever dimension analysis basically. So I'll give a question. You can try it now. I'll give you around 2 minutes, 3 minutes, the dimension analysis. This duties cannot be open. I saw that. Open කරගන්න බැරි scene එකක් තියෙනවානේ. Yeah, it's okay. We'll do that one from the theory note. Which one is the theory note? No, this not this one. Yeah, I'll give you a question. Give me 1 second to give create a question. Do we have any so for that I give me 1 second. පොඩ්ඩක් ඉන්න අපිට තියෙනවද බලමු. Do you have any question from the last week's sessions? I mean, any suggestions from the tute? Do you have any suggestions to do this question within the class like that? Okay, then I'll give you a question. But before going to Vernier Caliper and these measuring equipment, I need to do a question from the last week sessions. I mean, as a homework, I'll give you a question. Give me an answer. And this one is cannot be opened through the sorry, පොඩ්ඩක් physics. Okay. So okay, let's do this question because you are getting the paper. You are getting a paper from these parts. So I just want to make sure that your dimension knowledge is perfect. That paper will be on. I mean, after the April. I mean, you are getting the New Year holiday now. So after that one, you will get the paper. Okay. Those things will be notified through the groups. So write down this question. I'll give you a question. Q. Write this example in your book before going to the measuring equipment. Q. It has been discovered. It has been discovered. It has been discovered that the last drop of liquid, that the last drop of liquid falling from a pipe Write down this one in your book from the last week session. From falling from a pipe. Last drop of liquid falling from a pipe. Oscillate for some times. Oscillate for some time before being released. Before being released. The newcomers can write down this one as in a separate note, because this is a question from the last week session. The oscillation frequency f of such a drop depends on its density in density rho, depends on the density rho, radius r, and the surface tension of the liquid T, Obtain a relationship between them. So normally when you are getting such question in your term test, there is a description. Okay, so there is a description about the application. So there is a description about the application, and finally they are asking you to derive an equation, obtain an equation for this oscillation time. Obtain a relationship relation between them. Means you need to derive an equation. Do that. I'll give a hint, not a hint. I'll give a additional information about the surface tension. I think you don't know about surface tension dimension. Okay. So you don't know about surface tension dimension. I'll give you the surface tension dimension. It's okay. So this is the question. You can try that. So dimension of the surface tension T. You can take that one as M T minus 2. T minus dimension of surface tension is T minus 2. Okay. Complete this. I'll give you 3 minutes. If you have a question, you can ask. I'm giving you an example. I'm giving you a question to complete before we start in the what we call the measuring equipment, because we did only 2 questions in the class. So I need to make sure that your performance based on I need to make sure your performance about this dimension is strong, because in the next paper we have a special paper arranged for you. There are so many dimension questions. Okay, do that. If you have a question, you can ask. After finishing this one, we will move to the what we called measuring equipments. Complete this one. Dimension of surface tension. This is surface tension. T is the surface tension. Rho is the density. I think you know about rho density. This is radius length. And here they are asking the frequency. Frequency means, I think you know about frequency. I'll give another hint. Frequency means 1 over time. Frequency means 1 over time. 1 over time. That means dimension of frequency equals t minus 1. Because time dimension, this is 1 over time. Frequency 1 over time. That means dimension of frequency is t minus 1. Density තොදව කරන්න, but you need to remember that density, I think you are familiar with density is mass over length. Mass over length. So dimension of density is mass over volume, sorry, not length, mass over volume. Density means mass over volume, means m L minus 3. You need to know about these stuff. Radius, dimension of radius is the L. Complete this. I'll discuss that one 7:15. උත්තර ගත්ත කට්ටිය මට එවන්න. You can chat with me. Let's see your answers. Some of the answers are correct. පොඩි ප්‍රශ්න හරිදිච්ච තියෙනවා. I'll tell you. Others can do that. Taggalkar, I'll discuss it now. Okay, let's discuss about the measurement tubes. You will get the measurement tubes as soon as possible, because still that one is not finalized. I mean, it's finalized, but not yet transferred. I mean, not yet delivered. You will get that tube within this week, not within this week, after this week. Today, for today work, you don't need the tube. Okay, for today's work, you don't need the tube. No need to worry about tube. Okay, let's discuss that. Give me 1 second. පොඩ්ඩක් ඉන්න paper එකක් තියෙනවා මට ඒක print එකට දාලා ඉන්න. Give me 1 second. Okay, so let's discuss. මම answer කියන්නද? So check this whether you can get this answer. මෙන්න මේක තමයි ගන්න ඕන answer. Final answer. Frequency f. This is the frequency. You need to get k is the dimensionless constant. Divide square root of t rho r to the power 3. This is the answer. Check this one whether you can get it. Okay. බලන්න හදපු කට්ටිය, you can check this one whether you can get the answer. හරි, අපි වැඩි පටන් ගමු. තප්පරයක් දෙන්න. Okay. Yeah, so let's try it now. Let's try this question and let's move to the. Yeah, I'll do this question. I'm doing this question. No need to worry. Okay, so this is the answer, but I'm doing that. I just show you these things because then you can verify. The other students can recheck their answers if it is not correct with their calculated one. So how do you get the answer? So first thing, these are the important first step. I mean, when you take this one as stepwise approach, the first step is you need to write the relationship first. You need to write the relationship first. So the thing is frequency. They are asking you to derive an equation for frequency, and in this paragraph, you can see they're suggesting. This is a suggestion that frequency depends on the density. So we can take first suggestion is frequency depend on rho, but we don't know whether frequency is a direct proportional rho to the power 2 or rho to the power minus 2 or minus 1. We don't know about that, the power, the index. Because of that, what we can do, if direct proportional rho to the power x, we need to find it. Rho is the density. So then again the second relationship is frequency direct proportional radius to the power y. Then frequency direct proportional surface tension is capital T to the power z. So then let's take this one. This is the first step. You need to write all these relationships using direct proportional mark. Then from 1 to 3, you can write one expression. F direct proportional rho to the power x. You can connect all these things to one expression: rho to the power x, r to the power y, t to the power z. Our ultimate goal is to find these x, y, z unknowns. Okay, so then here this is just a direct proportional mark. So we need an expression or equation. So what we can do, we need to remove this direct proportional mark by using equation and an equal sign and the k. K is whatever constant. So how do you remove the direct proportional mark? Using equal sign and a constant. This is the way to remove this direct proportional mark. So then F equals k times, you can write rho to the power x, r to the power y, t to the power z. Okay, so finally we derived a relationship or an equation, but still we don't know about x, y, z. So what we can do now, the second step, first step is get the relationship like this. Second step is you need to take the dimension of the both side. You can write take the dimension of the both side by taking the dimension of the both side. By taking the dimension of the both side, what we can get here, dimension of frequency equals dimension of, you know, this case is proportional. I can indicate here, but no need, because dimension of that and also remember that in the exam you need to write this k, you need to define this k after introducing that k, you need to define it. K is a dimensionless, you need to write this stuff, okay? Dimensionless proportional constant. Dimensionless constant. Then frequency f equals, we can write k, if you want you can remove that k, doesn't matter, rho to the power x, r to the power y, t to the power z. So you can take the dimension of frequency separately. Dimension of frequency equals, we can write dimension of rho to the power x, dimension of r to the power y, dimension of t to the power z. So now you need to take the dimension. Dimension of frequencies, I told you, that is t minus 1. So dimension of density is m l to the power 3 to the power x. Dimension of L, radius is L, so L to the power y. Dimension of this is surface tension, so that is m t minus 2 to the power z. So in next case is, you need to write that here this side there is no m terms, m to the power 0, no L terms, L to the power 0, then there is a t minus 1. This side, let connect all these, let write an expression including, bring all these things together, bring all the m terms together. You can take, this is there is m here, m to the power x, and there is a m to the power z. So you know that whatever a to the power x into a to the power y, you can write that one as ax plus y. If these are connecting with the same base, you can write x plus y. So likewise here you can see m to the power is x, m to the power z. So you can write x plus z. Then L, you can see L to the power 3 to the power x. You know that when you take a squared and there is another third power, then you can write a to the power 6, 2 into 3. So likewise here you can write L to the power 3 times x means L to the power 3x, and here there is a y here, so 3x plus y, yeah, that's only the L term. Then what about t? You can take t, there is only 2 minus 2x z. This is about the t. Now you can match the terms. So now I'm taking the m. So then when you take m, you can take, now what we can do, so after writing this what we call the dimensions, now our goal is to match the index numbers of the corresponding base. So by taking m base, I can write x plus z equals 0. By taking L base, you can take 3x plus y equals 0, like that we need to write. This is the third step. Okay, now what we can do, by considering the each base separately, you need to match the index. So x plus z equals 0. Then by taking L, 3x plus y equals 0. Then t minus 2z, x equals minus 1. From that one you can take z equals half. If z equals half, from this expression you can take x equals minus z, then you can take x equals minus half. X equals minus half. Then what about y? You can see y equals what? Y equals minus 3x. Means now you know the x value. You can take minus 3 into minus half. So it's become 3 over 2. 3 over 2. So now we calculate the xyz terms. So now you can write, so we calculate the xyz terms. Okay, so now you can indicate the first equation again with the xyz term. So we can write x equals k is the dimensionless constant. Okay, then rho to the power x minus half r to the power y 3 over 2, then t to the power z means again half. Okay, so you know this half means square root. So let's take 2 to the power half means square root of 2. 4 to the power half means square root of 4. Very simple thing. So here let take this minus half. So I would like to write the minus half as 1 over root 1 over value. So k r to the power 3 over 2 t to the power half divided by rho to the power half. Minus means 1 over. Okay, so you can see this is 3 over 2 means you can see this is square root. You can take total square root half. I'll take the half out, much better. I'll take this one r to the power 3 t divided by rho to the power half. So I can take the half as a common index. Okay, so that means half power means square root. So frequency equals k times square root of r to the power 3 t divided by rho. I think this is the answer. Let's see. Yeah. Give me a second. Give me 1 second. There's a error in this one. Give me 1 second. Give me 1 second. Let's see whether I did some mistake here. Yeah, I did a mistake here. Here this one is L to the power minus 3. Sorry. Rho means L to the power minus 3. L to the power minus 3. A mistake L to the power minus 3. Sorry for that. I think I gave it here. L to the power minus 3. L to the power minus 3. L to the power minus 3 means this one should be minus 3xy. Minus 3xy. So this one should be minus 3. Okay. So this one becomes plus 3 then. Plus 3. So this is plus and this one is minus. Correct it. Okay. So in this one it should be m. You know that density means mass over volume. Mass over volume ml minus 3. ms minus 3. So then this one becomes minus 3x plus y. So this expression, this one should be minus 3x. So then y equals plus 3x. So we identified x equals minus half. So then plus 3 into minus half is minus 3 over 2. So this is minus 3 over 2. This one also need to move to the denominator. Sorry for that mistake. You can see you need to recheck about your final answer again. After doing the calculation, recheck your final answers, whether your calculations are perfect or not. If you are doing a simple mistake, finally your answer is completely different one. So then this is the final answer. Yeah, now it is correct. Sorry for that mistake. Okay, so now let's move to the our question. So I'm getting a lot of answers. So I'm getting a lot of answers. That's good. Yeah, I saw that my mistake. Sorry for that. Yeah, good. මම give class ගැන හිතන්න එපා. Yeah, I did A-levels in 2019. Okay. So I also went to a famous tutor. Tutor means a physics A-level teacher. So my fundamentals, my teaching methods also similar to him. Okay. Because he is my physics teacher. Okay. Yeah. So let's move to the. So let's move forward. Let's move forward. Okay. හරි නේද? Do you have any question based on this one? Do you have any questions? No, ne? Okay. So now let's move forward. අපි වැඩේට යනවා. Today video we will share this one to the group. For today, yeah, this is the first day of the practical one. For today video, we will share to the group. Other videos will give you how do you watch the previous videos, because these are not still uploaded to the I mean those are uploaded to YouTube, but you can't purchase the March card again after releasing the April month. I mean for the future reference also, after releasing a new month card, you can't purchase the previous month class. Okay, previous month recordings. So if you need any previous I mean if you need April month class before releasing the new month and the May card, take that April month. Otherwise you can't access the previous month. I mean if you need to buy the previous month card, but it's not available. But I'll ask with the Anuradha sir and let you know how to share these things for the new students. But definitely we will create a method. I mean we will announce that one, because there are so many new students engaging with this program. So in the Sinhala medium also. So we will give you an exact way to watch these previous week recordings. Okay. So now today we are moving to the measuring instrument. So write down the heading measuring instrument. Okay, measuring instrument. හරි ලස්සන scene එකකට යන්නේ. So we are moving to a new chapter, measuring instrument. Okay, measuring instrument. අද සුපිරියක් කරමු අපි. හරි, measuring instruments. මම ලොකුවට ලිව්වා. Always the recordings are uploaded to the website ap.lk. So recording is there, recording on, yeah, record there, no? Measuring instrument. So when you take measuring instrument, remember that when you take measuring instrument, what are the measurements that you are taking normally when you are doing practicals? What are the main important measurements that you are taking? We are taking temperature, yes, but there are thermometers. There are no specific other device in your A-level syllabus. But when you take length, there are so many instruments. There are so many instruments you can use for length measurements. There are different type of measuring instrument. So the basic one is the meter ruler. So now focus on this one. So today I am going to start the new lesson, measuring instrument, and definitely you are getting these question. Definitely one MCQ. Sorry, there is a one MCQ from this part, one MCQ, just a one MCQ. But this one is important. I mean, this one is important because you know there are structure shape equation. There is a structure shape paper. Sometimes you might get question from this part also. 2024, there was a question from the micrometer screw gauge. There is a practical equipment. Direct question from micrometer screw gauge. Okay. So likewise, these things these things are practicals. So the structure equations are based on practicals. Okay. So the other important thing is here we are learning about the measurements, the measuring methods. So let's take you are doing some other practical like heat practical or current electricity practical, but still you need to measure the length. you need to measure the cross-section area of whatever conductor or simple a wire. You need to measure the cross-section area or diameter. You need to calculate the cross-section area, but you can't directly calculate the cross-section area. You can measure the diameter. Likewise, for that measurements, you need to have a basic knowledge about the measuring instrument. Okay, you need to know about the basic knowledge of measuring instrument. So today we are learning about the measuring instrument, and that's our primary goal. Okay, so when you take measuring instruments, so what are the measurements that we are regularly taken? I mean, what are the measurements that you are taking in the laboratory? The first thing is length. Length. Okay, for length measuring instrument, to measure length, we have so many equipments. Okay, so you know your famous one is meter ruler. You know about this meter ruler. Okay, so there's a half meter ruler also, but doesn't matter, meter ruler. Not the foot ruler, okay? Not the foot ruler. I don't have that one here. You're not the foot ruler. This is the standard equipment, meter ruler. Foot ruler means in day-to-day life we are using foot ruler. Again, that's plastic one. Here, I'll explain the difference between the meter ruler and the normal foot ruler. This is meter ruler. And then now you are moving to a new measuring equipment. I mean, to measure the length, Vernier caliper. Our first equipment, Vernier caliper. Then micrometer screw gauge. Micrometer screw gauge. Then spirometer. Then finally, traveling microscope. Traveling microscope. Write down these stuff. So when we take measuring instruments, you are one of the measurement is important measurement is length, and then one of the basic length measuring equipment is the meter ruler. And here we are working on laboratory equipment. Okay, there might be some other measuring equipment. We are working on the laboratory equipment. These are available in your laboratory, physical laboratory. So meter ruler, Vernier caliper, micrometer screw gauge, spirometer, traveling microscope. Today class will be uploaded to April. For the last week, I mean, we did units and dimension part. From that section, for A levels, you are getting only one MCQ. First, with the very first MCQ, you are getting from the units and the dimension. But the entire physics based on units. I mean, if you are doing calculations, if you are doing substitutions, I told you, you need to have a unit conversion. That means without knowing the unit conversion, you can't do, you are not able to do the calculations. You don't know how to unit convert. You don't know the SI units. You don't know about the prefixes, suffixes, unit conversions, or simply you don't know the basic. I mean, there are some tricks based on dimension. So there are some tricks to get the answer quickly based on this dimension. So likewise, without that knowledge, you can't move forward. So that's why, as the first lesson, we are giving the information or the theory parts about the units and the dimension. Without having the units and dimensions, you can't move forward. How do you write an equation? How do you write an length without knowing the unit? The length measuring unit is meter. So then how do we convert meter to centimeter to millimeter, micrometer? You need that. Remember that. So first lesson is also very important, but you are getting only one MCQ based on that lesson. But the entire other lessons or whatever thing, I mean, essay or structure essay, you need the units. Length. So I think you are familiar with the meter ruler, but all these four devices, there are four devices here. I think these are new for, I mean, there might be some students already familiar with this Vernier caliper. Personally, in my case, I before coming to LOS, I personally know this equipment, Vernier caliper, only the Vernier caliper, not the other case, because sometimes in industry they are using these Vernier calipers most of the case in industry. Okay, so that is length measuring equipments. So the other one is mass. So to measure mass in the laboratory, don't write that chemical balance. Okay, chemical balance, that there's an equipment known as chemical balance, but not most of the time you are not using that. That one is like a fancy item. Not that one is not a fancy item. That one is a very accurate equipment, but you are not using that much. Okay, so those things are there in the laboratory to display that these things are also available. Okay, so normally what are the regular equipment you are using for mass measurements? We can take triple beam balance. Triple beam balance. Then there's another one, quadruple beam balance. සිව් දණු තුලාව. මේක තුනක් තියෙනවා එක හතරක් තියෙනවා. හරි. But that one is also not used that much, quadruple beam balance. But yeah, some laboratory that one is also available, quadruple beam balance. There's another one. I mean, 4 beam balance කියලා කියන්න පුළුවන්. 4 beam balance or quadruple beam balance or 4 beam balance. Simply there are 4 beams, and most of the time you are using triple beam balance and electronic balance. Okay, so then other thing is time. So when you take time, how do you measure time? Stopwatch. So we have analog stopwatch, analog stopwatch or digital one. Or digital watch. Digital. Meter ruler, Vernier caliper, micro screw gauge, spirometer, traveling microscope. Those are new thing for you. But I think you are familiar with these things somehow. I think you know what is triple beam balance. I think you know what is electronic balance. I think you know about this analog one. I mean, if you take your phone, mobile phone, you can take the digital stopwatch. When you take your phone, mobile phone, there is a stopwatch. Okay. So these equipments, you need to have a clear idea. So these are the main 4 measurements you need to take. But let's say you need to take the temperature reading. Then you need the thermometers also. So then we can normally we can use glass thermometers. So under heat, there is a new session. I mean, there is a thermometry part, thermometry. So under that you can learn about the thermometers and what are the different types of thermometers like that. So because of that, we are not teaching the temperature measurement here, but simply you can use the thermometer, glass thermometer. Like that, there are laboratory thermometers also. Normally they are using alcohol thermometer to measure the temperature of the environment. The mercury glass thermometer is also there. Yeah. So now let's move to the first part. Do you need any photos of this? I mean, no need. Okay, but if you want, I can show you. Give me 1 second to show these things for you guys. I'll share my screen because the single medium tube is available here. I'll show that one from this one, from this single medium one, because English medium one is not printed yet. English medium tube, because after releasing the single medium one, we need to translate it. So still now we translated, but not yet printed. Okay. So you can see this first one. This first one is the meter ruler, and the second one is the Vernier caliper. This one is the micrometer screw gauge, and this one is the spirometer. This is a very small one. Okay, that spirometer is very small thing. It's not that much large. But traveling microscope is like you know about the normal microscope. Likewise, it's a huge one, but spirometer is very small. It's like 5 centimeter. Then this one is the triple beam balance, then quadruple beam balance, then electronic balance, and finally this one is the analog stopwatch. Analog stopwatch. Okay, did you get that? So you can receive this one tomorrow. I mean, single medium students. For single medium students, English medium student, you can't get it yet because it's still not printed. But it's printing this week because this one is finalized on Monday. So that's the problem. So because we add some more new thing. So in last year students, they didn't receive this much information in this tute, but we add a lot of things for you guys. Good with this tute is it contains a lot of data. Okay, lot of information. So I will repeat it again. First one is the meter rule. Second one is Vernier caliper. This is the micrometer screw gauge. This is the spirometer, and this one is the traveling microscope. So this is the triple beam balance. This is the quadruple beam balance. This is the electronic balance, and then this is the stopwatch. Okay. Yeah, that's it. No need this tube for today session. I just want to show you the images of the equipment, and then we can move to the yeah, here in this tube there are different types of errors. So when you are taking measurements, there are so many errors occurred. So in this tube, I mean when you are receiving the tube, you can also see the first part is that one based on that first chapter in this, I mean first pages. You can see there are theories about the errors, but I am doing that one after discussing the length measuring equipments. Otherwise you are not getting the meaning of these errors. Okay, now let's move to the meter rule. Meter rule. Okay, so Saturday students might be get the English medium tute, but let's see. I'm not sure, but doesn't matter. No need the tute for your studies. I mean, you can go through. I'm giving the total. I mean, I'm giving the note for you. You need to write it. Okay, so so last day also when you are doing units and dimension, I didn't go through the. I didn't check the tute. I gave you my own note. I mean, I gave you the theories. So you prepared your own note. So then finally you can follow that one. The tute is there to do some questions, to do the exam. There are examples on the tute. So you can use the tute as some supportive material. But I am creating the note on your book. Okay, so now let's move to the length measuring equipment. First thing is the meter rule. Let's start from the meter rule because there are some things you need to know about the meter rule. You can guys think that meter rule, what is that? Yo, it's a very basic one. Why we need to learn it again? But you need. As I mentioned, the foot rule and the meter rule, there is a difference. Okay, so let's start the meter rule. Write down heading meter rule. When you take meter rule, there are two types of meter rulers available in your laboratory. One is, as I mentioned, is 1 meter exact 1 meter length meter ruler, and the half meter ruler. Half meter means its length is 50 centimeter. It's a half of the big one. Okay, there are some half meter rulers also. Hitam bhagya. So its length is 50 centimeter. So when you take meter ruler, I think you are familiar with the meter. So then let's discuss what are the difference between the normal foot rule and the meter rule. That is the important thing. That's one about the zero. Okay. So when you take a meter ruler, I'll show you a meter ruler. We can Google it. I don't have a meter ruler. I didn't buy it. I can buy and show, but those meter rulers are also not accurate. I went to the bookshop and searched meter rule. Those things are plastic meter rules, and the edges are not perfect. Because of that, I didn't purchase it. Useless to buy a meter ruler like that. So these are the meter rulers. Okay. So let's take a meter rule. Meter rule again. Sorry. So let's take a meter rule. Yeah, before going to the Vernier caliper, I need to explain about the meter rule. So let's check a meter rule. Last meter rule. There are so many meter rules. Okay, this one is good. Okay, now check this one. So take your foot rule, normal foot rule. There it might be 15 centimeter or 30 centimeter. Take that one. Take that one from your pencil case. And check with where is your zero there. Check where is zero locates on the plastic meter rule. Check this location of the zero. The location of zero is not at the edge of the meter ruler or the foot rule. There is a gap between the edge of the, I'll show that one also, normal foot rule. Let's take a normal foot rule also, because I need to compare the difference between the foot rule and the meter rule. Because sometimes in the exam, if they ask to write these things, I mean in the lab, you need to measure a certain length. If you write as a foot ruler, they are not giving marks. Foot rule is not laboratory equipment. Foot rule is not a laboratory equipment. Foot rule is just that one is there for your day-to-day work, but not a laboratory equipment. So if you take a foot rule, you can see here. You can see here your zero. The zero reading is not at the edge of the ruler. Your zero location, your zero reading, your zero division is not at the edge. Okay. Your zero is not at the edge. So because of that, you can't use this one to measure height. So let's take, you need to measure height. So I'll explain that one. I'll draw that one and show you. So if you, I'll come back to the, I'll show you that one later. The concept, remember that. Remember this one, your zero is not at the edge. When you take a whatever foot rule, that one is not the corner. But when you take the meter ruler, your meter ruler zero, you can see this is 1. This is this is 2. This one is not good. This one is not good. I don't like that one, because there are no division marking. 1 millimeter divisions mark. I need to show you the accurate meter rule. This one is much better, but the edge is not visible. That's okay. So you can see in this one, sometimes the edge is not visible, but this edge is actually 0. So you can see it's starting from 1. Here it is 1, 2. This is the end of the, or this is the edge of the meter ruler. Okay, this is the edge of the meter, this end, and that one is the exact 0. Remember that. You can see this is 1. this is 2, this is 3, and this one is exactly 0. Exactly 0 means if there is no degradation, or if it is not wear out, if it is not worn out, then this one is exactly 0. Remember that. Hi. So the concept is, when you take the meter ruler, the edge of the meter ruler is exactly 0. That one is the manufacturing. I mean, if you take a new meter ruler, if you take a new ruler, then you can see the corner edge is definitely exact 0. මේක ලස්සනට පේනවා. මේක හොඳයි. This is a steel ruler. Can you see that? Okay. So you can see here, it's not that much visible, but I think it's okay. This is 1. This is 1. This one is 1. This one is 2. 3. This corner exactly 0. And you can say this is 0, this is 1. There are 10 divisions. That one is observable in your foot rule also. So let's take this is 1, this is 2, 3. Let calculate the number of division between 2 and 3 in your normal rule. That one is also there in your normal rule. Calculate number of division. Tell me the number of division between 2 centimeters. I mean 2 centimeter divisions. Let's take this is 2 and 3. Between 2 and 3, just as chat. But tell me the number of division between 2 and 3 or 3 and 4, whatever. Again, I'm asking small thing. 10. Okay, so you can count the number of division between your foot rule or whatever. Number of division, the smallest division is 1 millimeter. So you know that when you take a 1 centimeter, if 1 centimeter divided again to a 10 divisions, 10 equal divisions, then size of that one division is 1 millimeter. Okay, that one is 1 millimeter. So when you take a meter ruler, the important thing is the difference between a meter ruler and the common foot ruler is that common when you take a foot ruler, you can see here. You can see here, this one, the edge is exactly 0. You can see 1, 2, 3, 4. Where is 0? 0 is this edge. You can't see the 0 actually. 0 but it's not indicated because this corner is the 0. You can see that 0 is not marked, but in your foot rule 0 is marked as 0 because there is a gap here, but here there is no gap. Because of that, this is not indicated as 0. So remember that meter rule always starting from 0 and your finishing point, that one also not indicated as 100. That one is also finishing at 99. So 100 is the other cone. So here you can see, in this case, this corner, again you can't see, this is 99, okay? This is 99 centimeter, 990 millimeter. Just think that one as 99 centimeter, 99 centimeter, okay? 99 centimeter, I think this one is indicated by millimeter. That is 999 millimeter. So then this one is the 1000 millimeter or 100 centimeter. That again, that one is not indicated because that corner reading is 100. Corner reading is 100. Remember, this is 100 means in centimeter, okay? Millimeter 1000. In this side, you can see. In this side, you can see. This is 1 centimeter or 1 centimeter or 10 millimeter. They indicated this value in millimeters. Okay, that's okay. So this is exactly 0. These are the laboratory equipments, not like your daily usage foot rulers. So this is exactly 0. That one is other side is exactly 100. Or because of that, space is not sufficient to mark that 0 and 100. So it's not marked. You can see it's not marked. Okay. So that's the standard meter rule. Okay, this is the standard meter rule. So if someone asks, I mean in the exam, if there is a question about the length measuring equipment, don't write foot ruler. I'm again explaining it. Don't write foot ruler because foot ruler is not a laboratory equipment. Meter rule is a laboratory equipment. Okay, So now let's move to the, no need to draw this stuff, no need to draw the meter ruler here, but you need to draw for a particular calculation. Okay, so meter ruler. So again, write down this one regarding the meter ruler. Yeah, you need to write this. Meter ruler can be used. Meter ruler can be used. Meter ruler can be used to measure the length. To measure the length. To measure the regular length. Regular length. To measure the regular length. Meter ruler can be used to measure the regular length. To measure the regular length in the laboratory. In the laboratory. In the laboratory. And it is designed. The meter ruler can be used to measure regular lengths in the laboratory, and it is designed and it is designed and it is designed and it is designed this is the left side now. And it is designed exactly 1 meter long, and it is designed exactly 1 meter long. Exactly 1 meter length is length in size. So it is designed exactly 1 meter length in size, and it is designed exactly 1 meter length in size. By indicating the exact 0 and 100 divisions, exact 0 mark and 100 marks. So by it's exactly 1 meter length in size. By indicating the 0 mark, the 0 mark and the 100th mark, the 0 mark and the 100th mark exactly at the corners, exactly at the edges. Okay, it is 1 meter exactly length in size, and which indicates the 0 and the 100 mark exactly on the edges. 0 and the 100 mark exactly on the edges. Okay, exactly on the edges. Item bindu 100 mark, that is a manufacturers manufacturers are doing that. Those stuff, the 0 might be worn out, but there's a problem like that. Let's see what we can do. Okay, then write. So exactly the 0 mark and the 100 mark exactly mark on the edges. By indicating, I told you that by indicating the 0 and the 100 mark exactly on the edges. Okay, then write down another point. This meter ruler divided, this meter ruler divided, this meter ruler divided, this meter ruler divided, this meter ruler divided into 1,000 divisions, 1,000 divisions. This meter ruler divided into 1,000 divisions. Thousand divisions means the size of the smallest division, the size of the smaller division. This meter ruler divided into 1,000 division, and the size of the smallest division is, the size of the small division is 1 millimeter. 1 millimeter. 1 millimeter. This 1 millimeter, this meter row divided into 1,000 divisions, and the smallest division, and therefore, and it means, I told you, it means this meter row divided into 1,000 division, and means is smaller division is 1 millimeter. The size of the smallest division is 1 millimeter. Okay. Okay, so then write down this one also. Then using this meter, so you can write like this. So it is exactly 1 meter. You can see there are centimeter divisions. There are local divisions in here. Homarkle 1, 2. So those are not the smallest division. Okay, so there are certain marks like that. So those are marked using centimeters. So you can see 1 meter divided to 100 centimeter, and then again 1 centimeter is divided to 1 millimeter. You can see it's 1,000 millimeter. So normally there is a thing known as least count. There is a thing known as least count. Least count is the smallest reading that you can take using one of that measuring equipment. Okay, small least count is the smallest reading that you can take using whatever equipment. So here it is meter rule. So what is the smallest reading that you can take? 1 millimeter, because that is the smallest readable point that we can see in the meter ruler. Meter ruler, you can see 1 centimeter again divided into small 10 divisions. So because of that, using that equipment, the smallest measurement that you can take is the 1 millimeter, known as its least count. So write down this one. Least count is the, write down this one, least count. Least count is the smallest measurement. Least count. Okay, least count. You are always using this term after this introduction. So now I introduce this term, least count. So now you can see that term always comes when you take a whatever measuring equipment. So least count is the smallest measurement that we can take. Least count is the smallest measurement that we can take using a measuring equipment. Using whatever measuring equipment. Least count is the smallest measurement that we can take using whatever measuring equipment. when you are taking the class cards, I mean April month, I think there is a option to register as English medium. I mean, there is no such English medium separate class card. But when you are filling your data, I think they are asking you to. They ask. I mean, when you are filling your bio data, I think there is a separate section. I'm also not sure, but if you are not sure about that, tell me. I'll ask. I think there is when you are filling your bio data, they are asking you whether you are doing English medium or single medium. Based on that one, you are receiving the English medium tutols or the single medium tutors. Okay. Yeah, least count is the smallest measurement. Least count is the smallest measurement that we can measure or that we can take using whatever equipment, whatever measuring equipment. So then what is the least count of the meter ruler? So then it's again, then least count of the meter ruler is, least count of the meter ruler is 1 millimeter. Write down the least count of the meter ruler is 1 millimeter. Least count of a, so I told you that least count is the smallest measurement that we can measure or that we can take using whatever measuring equipment. Least count is the smallest measurement that we can take using whatever measuring equipment. Doesn't matter when you take least count of the stopwatch, then that one is the smallest measurement that you can take using the what we call stopwatch. Okay. So what is the least count of the meter rule? Least count of the meter rule is 1 millimeter. So simply you can write LC. Least count is 1 millimeter. You can use that one as a short term, least count LC. That's okay. Okay. I mean, they know that it's a standard way to represent it. Yeah, I think there is a thing to form in that form. There is a separate one to fill whether you are doing EM or SC. Based on that one, they are sending you tubes. Okay. So what is, foot roller? I don't know the exact reason why they are not sending with that. As I told you, meter ruler. This corner one is exactly 0, but you can't see that 0, okay? Because a 0 is not indicated. You need to know that you can see there are small division, and then you can see this mark as 1. So this side is the 0. But your foot ruler, it is not marked like that. Foot ruler, there is space. I think that one is maybe I don't know the exact reason. Might be if to observe that one as 0, to measure to get a rough idea where 0 locates. But for meter ruler, you don't need that one. I mean, we are using this meter ruler to measure heights. So let's take why we need this one. So I told you, so meter ruler, very important thing is the edge is marked, edge is 0. So now, so let's take a certain practical usage of the meter rule. So now I need to measure the height. So I need to measure the height of this water bottle or whatever equipment is there. There is an object here. What we can do, let's take a flask or vacuum, not vacuum, hot water flask. I need to measure the height of this. Let's take a cylinder, simple place. Cylinder. There is a cylinder. I need to measure the height of the cylinder. There is a cylinder, cylindrical object. So what we can do, so this is the table. So this is the table. This is the table. Okay. So then if you are using a meter ruler, so we know that the other side is exactly 0. The edge of the meter ruler is exactly 0. So then if you are taking a brand new meter ruler, brand new means I know that then definitely your edge is 0. හරි නැත්තම් සමහරලාට ගෙවිලා ගෙවිලා බිඳුව හරි බිඳුව නෙමෙයි ඒක එහෙම වෙන්න පුළුවන්. Okay, so this is the meter ruler. So now you can take, so this is my meter ruler, this is my meter ruler. Okay, so then we know this is exactly 0. This is exactly 0. You can't see that. You can't see that one is not indicated as 0. But here you can take let's say these are the readings, 1 millimeter readings. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1 centimeter. Likewise is indicated. I'm not mark it. Okay, so then how do you measure that? So definitely this one is 0. So then to take these kind of heights, you can directly use this meter ruler because this is 0. And then to get a better value, you can keep a square, set square, get a set square here, get a set square and keep it on the cylinder. This is a set square. These are standard ways to measure the height. So what we can do, we can take a set square. This set square. Then keep that set square on this side and take the reading by looking. But you can take the direct reading here. You can take the direct reading here. Remember that. Okay. So here, if it is not 0, then you can't do that. So using regular fruit ruler, since this is not 0, there is error. But meter ruler is standard equipment. They design that this edge is marked as 0. They design to get this edge as 0. So because of that, you can directly take this reading using the meter rule. You can directly observe that one. Yeah. Okay. So why we need why no need. So you can take the height. I mean, no need to write as a heading. Just like so I need to measure the, let's take this is the edge. I need to measure the height of, sorry, I need to measure the height of this cylinder. Just draw this one. This is the height of the cylinder. So I need to measure that height. So how do you take it? So you can, if you want, you can just mark some small divisions. Make a number, just mark that not needed. Okay, so likewise, it's this is the meter rule. Since this is exactly 0, to measure the height of the cylinder, we can use set square because then it's you can take the readings accurately. Set square. This is a meter rule. So you can obtain the, so in the can obtain the height directly from the meter rule. If you want, you can add some other division marks. Doesn't matter, you can mark that. Okay. Take the reading directly. Can obtain the height directly from the meter ruler. Can obtain the height directly from the meter rule because this one is exactly 0. Okay. But using a foot ruler, you can't do that because this is not exactly 0. Draw this one. The importance of the meter ruler. This is the part of the meter ruler. This is a part of the meter rule. You can take direct measurement. Okay. So it's better to use a set square then you can take the collinear, I mean the collinear reading. This one is co-align. Co-align means it's aligned. These two align. So we can take the reading without any error. So when you are taking the reading, sometimes there are errors, observation errors. You are not taking the readings correctly. I mean, you are not taking, or you are not observed. So I'm marking that error also. Just draw this one. Since this one is exactly 0, you can take the height directly. So for ruler, it's not good to measure the heights because that edge is not 0. Okay, mark that one. Okay. And also, but due to the higher usage of the meter rulers, due to the higher usage of your laboratory, there might be meter rulers. They are using those things long time, and they are keeping all these meter rulers always in a vertical position. You know that they place in a vertical position. So sometimes these edges might be worn out. So then this is not exactly 0. Then this is because you know that 2 millimeter, 3 millimeter might be worn out. Then there are errors. So as I mentioned, if you want to measure, if you want to take this kind of height, take a new meter ruler, brand new meter ruler. Otherwise, you don't have any other option. Take a new meter ruler to take these kind of measurements. Otherwise, there are errors. Okay. Remember that one also, that as a guidance when you are doing the practical, as a proper, I mean, as a guidance, always choose a new meter ruler to obtain the heights, because otherwise your 0 might be worn out. Gavila. Okay. So now I told you the least count is 1 millimeter. That is the smallest reading or smallest measurement that you can take. What is the maximum measurement that you can take? 1 meter. So that means, let's take, I need to measure the height of this wall. Then you need to take several meter rulers. Okay, you can keep one top. You can keep 1 meter ruler on top of the other one, because it's exactly 1 meter. Okay, so it is exactly 1 meter. If you are taking a brand new one, then that one is not worn out. That one is not wearing out. That edges are not wear out. So because of that, if you want to measure the height of the, let's take, I need to measure the height of this. I need to measure the height of the, let's take a cupboard. I need to measure the height of the cupboard. That one might be 3 meter height. So then you need several meter ruler. What we can do? We can keep one, because of this advantage. Because that one is exactly 1 meter. So then what we can do? We can keep 1 meter ruler on the other one. Stack. Because this one is exactly 0, this one is exactly 100, then this one is exactly 0, this one is exactly 100. Okay, you can keep one. I mean, if you want to measure higher, I mean, if you want to measure these kind of heights, you can let's take the height of the cupboard. Then you can use several measurements and several meter rulers. Sorry, several meter rulers, brand new one, much better. And you can keep one on the other. You can keep one on the other meter ruler, and likewise you can stack and measure the total height. Okay. If you want, you can draw that. I mean, no need to draw, but that is another advantage of this 0 and 100. So let's say this is the cupboard. I need to measure the height of the cupboard. Because of these 0 and 100 marks, you know that those are located, those are placed or mark on the edges. So, but normal foot ruler you can't, because there are small spaces. The corner is not exactly 100. Then you can't take that one to measure the you can't use that one to measure the height here. So you can stack the meter rulers on top of the other and take the final measurement. Because of this 0 and 100 divisions, they are locating at the corners. So these are some practical advantages. That's why I'm telling you, don't use meter fruit ruler for your what we called laboratory experiments. This is 0, this is 100, and this one is 0 again, this one is 100, this one is 0, and this one is 100. So you can keep the what we call set square again here and measure the reading. Then you can take the total height as the final addition. Here I am explaining the advantage of these meter rulers. Do you need a break today? Okay. Okay, I'll give 5-minute break. දැන් පුරුද්දට නෝනේ break. Yeah, it's okay. I'll give. මගෙත් වතුර ඉවරයි. වතුර ටිකක් ගන්න ඕනේ. Okay. So now you can draw that one also. So as a advantage of the meter rule, you can, since these 2 points are located on the edges, you can take a direct measurement by stacking the meter ruler one after the other. Okay, you can, if you want, you can mark a note, you can put a note there. Since the 0 and 100 is located or marked on the edges, we can stack one meter ruler on the other one and take the direct measurement. You can take the direct measurement. That is another advantage of this meter ruler. Now you can't write that use the measuring tape. So you know that the measuring tape you know that if you want to measure, you can use a measuring tape, but that measuring tape is not a laboratory equipment. Don't use that one if you want to measure the height of the cupboard. You can, what is the practical approach? Use some brand new meter rulers and a stack, or you can keep one on the other one, and likewise by keeping those things on a vertical arrangement, you can measure the total height. Okay, so then so I think now it is okay. So then due to the higher usage of meter ruler, due to the higher usage of meter ruler, the edges might be worn out. For such height measurements, there is no any other option. Okay, then you need to select a brand new one, because we are comparing this earth. I mean, we are taking relative, I mean, we can keep these both objects on the same plane and take the measurements. We don't have any other option. Take the brand new one. But let's take, due to the high usage of the meter ruler, the edges might be worn out. Then let's take, I need to measure the length of the pencil. I need to measure length of the pencil. Okay. For those kind of measurements, you can use whatever meter ruler. I mean, not the fruit ruler. You can use a meter ruler. Okay, that's it. Standard equipment. You can use a meter ruler, but you are not using the 0, because we don't know whether that one is actual 0 or not. Because of that, so let's say this is the meter rule. So we don't know this one is actually 0 or not. So I'm taking a piece of so I'm taking piece of meter rule. So let's say this is my meter rule. So the standard way to take the length of the length of the, let's take pencil. standard way to take the length of the pencil is that you should not use the 0 as the reference, because we don't know whether that one is actual 0 or not. Okay, we don't know that one is actually 0 or not, maybe worn out. But as I mentioned, remember, for height measurements we don't have any other option. Okay, so then you need to take a brand new one. So what we can do now, it's 3D unknown and just draw it. Okay, so here this is, I'm taking part of that what we called meter rule. Don't know, no need. Okay, no need to make that much detail. So the concept is, here I'm taking 10 centimeter division as my reference. I'm taking this is let's say this is my 10 centimeter division. So we know that one is exactly there. You can readable it, because I told you 0 is not observable. 0 is not there. 0 is not indicated at the edge. The manufacturers, they are manufacturing to make that to keep that edge as the 0 position. But due to the high usage, you don't know whether that one is actual 0 or not. Maybe worn out. Because of that, let's say you need to measure the length of the pencil. What we can do, keep that pencil closer to the meter ruler. Keep that pencil close to the meter ruler and take this measurable point, or let's take 10 centimeter point as your reference. 10 centimeter point as your reference. Then you know this one is exactly 10 centimeter. Okay. So then, relative to that point, take the measurement of your you can take this one as your first reading. You can take this one as your first reading, 10 centimeter, and take the next reading as your other side. I mean, if it is not readable, you can, I mean, let's take pencil, or let's take another cylinder. Pencil එක තුඩක් තියෙන හින්දා there is a cylinder, a wooden log. This one has a edge. When you take a pencil, again there is a pointer. So then you need to use a what we called because you can't take the exact reading. Then what we can do? We can take a set square again. We can use set square. So let's take here. This is the whatever brand new pencil without sharpening, or whatever cylindrical object. So here I need to take the measurement here. So if it is not, because of that, the concept, if it is worn out, we are taking another readable point as example 10 centimeter to take the reading, to take the measurement. So then you can see there are small divisions. This is 11 centimeter. Small pencil. Okay. So then when you take the measurements, another important thing, when you take the measurements, you need to observe directly above the edge. When you take the measurements, you should not, I'll explain again. When you take the readings, you need to observe directly above the corner. You need to observe directly above the corner. Here also, when you take the measurement, always observe directly above the reading. These are also very important thing. Otherwise, there is an error known as parallax error. I'll explain. When you take the reading, take the you need to observe vertically above. Then you can take 10 centimeter directly above. So take that one as R1. Let's take this one is R1. R1 is 10.1. Sorry, 10.0. Julian, I'll explain. 10.0. This one is 11.5. Then the length of the conductor, length of this cylinder, you can take R2 minus R1. Those are readings. and then 11.5 minus 10.0, it is 1.5 centimeter. In millimeters is 100 millimeter. This is 1115 millimeter. When you take a difference, you can get 15 millimeter. Yeah. Here in my case, I use the 15th one. In your case, you can use whatever reading here, doesn't matter. Let's take in your case, this one is collinear with the 11.4, right there. No need to write the exact one, whatever the concept is, you need to take this one. So remember that here you can make that side of the cylinder collinear. Collinear, this edge should be collinear with this reference. I am taking this one as a reference. And then relative to that reference, you can take this reading by observing vertically above. Take the measurements. It's important, okay? By observing vertically above. Take the measurements by observing vertically above. Draw that one also. Otherwise, there is an error known as parallax error. I'll give you that. So because of that, the concept is we are not using the edge as a reference. Because of that, I think if you want to write that, because of that, we can take the length of the conductor or length of the object, using another reference like a known point 10 centimeters. Take the measurement by observing vertically above. So this is the length of the conductor or length of this cylinder. Okay. I'm taking a part of this meter rule. Because I cancellate cancellate to take two readings like R1, R2. Because of that, when we are measuring these kind of things, not the height we can't do that. Then your edge should be exactly 0. But for other measurements, normally what we can do, we don't know about that because that 0 is not observable. We don't know whether that one is worn out or not. So our practical approach is don't use that 0 as a reference, or don't keep this one at the edge of the meter rule. Because of that, can keep the pencil to another reference, to another known point. Okay. If you are not observing vertically above, then because of that, can use another point as 10 centimeter in this example. As a reference. Reference means I'm taking that point as my first reading and measure the second one. Because of that, can use another point, readable point. Here in this example, 10 centimeter as a reference. Okay, these things are also important. ඔයගොල්ලෝ මොනවද මේ චූටි දෙයක් නැහැනේ. Vernier caliper පටන් ගන්න meter rule මොනවද මේ These things are important. That's why I'm telling you. Okay. So what is the error that comes with this problem? I mean, if you are not vertically observing. So let's take something like this. This is the plan view of that previous one. I'm taking the plan view of the previous one. Plan view. Okay, so this is the earlier one. So we need to vertically observe. I mean, we need to observe vertically above. So you can't see this one. Okay, you can. This is the edge. This is the edge. So then, as I mentioned, you need to observe vertically above and take this one as the first reading, 10 centimeter. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11 centimeter. 1, 2, 3, 4, 5. Okay, so this is the previous reading when you observe or when you take a plan view. Okay, so then you can take the R. This is the R1. This is the R2. Let's take now. You are taking, if you are not observing vertically above, height balanne. You are not taking vertically above. That means you are observing in this side. So then, okay. So here, how do we take a measurement? You are taking measurement relative to this one. I mean, you are taking the measurement. These things are not that much. I mean, the gap is not this much significant. Okay, I mean, these things are located very close. So when you take this kind of observation, you are not observed vertically above. Then what's happening? You are not taking this one as reading. So, or sometimes you can keep this one on the meter ruler also. You can keep this one on the meter ruler also. Doesn't matter. You can keep this one on the meter ruler. That one also okay. But the problem is when you do that, if you are not observing vertically above, there is an error known as parallax error. That means simply, okay. So I think you can see that the problem is here. If you take, this is my edge. This is the edge. So then if you are observing in this way, you are identifying the collinear division. You identify the collinear division in this meter ruler, and then let's take, you are taking this one as the reading. When you observe with a certain angle, sometimes you might be end up with this one. You end up with this one. Then you are taking this one as what is the reading? 9.9 9.9 millimeter. If you are not observing vertically above, then you need to find out the collinear division with the edge. So then you might be taken this one. So you are not observing directly above. You are taking side view. So then you can take these 2 points. These two, this is the edge, and then you can see these two are collinear. When you directly, if you are observing directly above, then you can see these two actually the collinear division. But if you observe from this side, then you can see this edge and this line, they are collinear. Then finally you are taking a different reading or incorrect one. And let's take now, I'm observing from this side, again same way. Then my vision, this is my vision, you can see my eye. Okay, this is my vision. So then I'm observing with a certain angle. Okay, open pain nag. So I'm taking certain angle. So not directly above. Okay, so if I observe with a certain angle, then these 2 points get collinear. Then your readings are not correct, known as parallax error. Parallax error. Okay, සමාන්තර නොවීමේ නිසා ඇතිවන දෝෂය. Parallax error. I'll show you that one. Let's Google it. I think my drawings are not that much perfect. Let's Google it and observe the sum of that diagram with that error, parallax error. Here, so this is a meniscus. Okay, this one. Let's take whether you can see it. Okay, this one is so here that person take this edge. That person need to take this edge. So if that person observe directly above, you can keep the nail closer to the meter rule, and then you are taking directly above. Then you can see the correct reading. But if that person is observing at a certain angle, then that person take this 5.2 as the reading. Okay, so this kind of error is known as parallax error. Parallax error. Sorry for that. I'll again repeat it. So here you can see this person can see the correct reading, and then this person observe with a certain angle, then you can see final reading of that person is 5.2. Not this is not I mean this one is not 1 millimeter. This is I think 2 millimeter. 5, 5.2, 5.4, 5.6, 5. This is not the exact one. This is not a good meter ruler. Just get the idea. Okay. So you can see here also there is another reading. You need to take the position of this spring balance. So here, if you observe from this side, your final reading is not correct. Okay. So here, this meter rule is not good. This one is not good, but take the idea. Draw that one also. What is the parallax error? Let's see whether we can get another one. Yeah, this one also okay. And මේක අඳගන්න පොතේ. මේ තියෙන superior. ගින්දර වගේ ෆොටෝ එක. මෙන්න මේක අඳගන්න. This is known as parallax error. I'll increase the size. Draw the එහෙම කද උනේ. දාන් වෙනවා ඩෝන් වෙනවා. මගේ අත ටච් වුණා. Draw that one. I think this is the correct reading. This is the so that person again measuring that meter rule is a good one. You can see this is a height measurement. So this is exactly 0. මේ බලන්න ලස්සන බිඳුවේ. අප superior තියෙනවා. That edge is not wear out. So then that person, when you are taking the height measurements also, you need to take the you need to observe vertically above. Here is not vertically above. You need to take the vertical reading. You need to take the what we called perpendicular. I mean, you need to observe the parallel to the reading. So these are this is the reading. You need to observe the read, or you need to take the read parallel to the readings. Hi, so make another tag. You can just mark this one. So if you take if you observe from this side, you can see that person take that reading as 6.5. That is not the correct reading. If you observe this one, this person take that one as 6. That is also not the reading. So you need to take the. So if you are taking this one on the table, if you are placing this one on the table, you need to observe vertically above. Height උඩින් බලන්න. Hi. හරියට මුඩින්ම you need to observe vertically above. Draw this one also and define that one as parallax error. මේ මම ස්පෙල් කරානේ PARALLAX parallax error. So you can write, if you are not observing directly above, there is an error occurs known as parallax error. Just write that one also. If you are not observing vertically above, there is an error occurs known as parallax error. We have a error calculation separately. I mean, there is a separate section. I will do that one later, but for this case, just write that when you are taking the reading, always just observe vertically above. හරිද? These things are important. මේව මට ටියුට් එකේ print කරලා දෙන්න තිබ්බ, but you need to write to get that experiences. Okay. Yeah. If you want, I'll keep that photo here. Okay. Known as parallax error. So if you are not observing directly above, in this case, I am talking about this case, directly above, there is an error. There is an error occurs known as parallax error. This is the parallax error. Then finally, you can't get the correct reading. This is the correct reading. But you end up, if you are not observing parallelly to the reading, parallel to the measurements, so you can see these are the lines. You need to observe parallel to that reading. So that's why it's known as parallax error if you are not observing parallel to the readings. Or in this case, directly above or simply directly above. ලියලා නැහැ හරියටම. පොඩ්ඩකින්. Observe directly above or parallel to the measurements. ලියන්න කම්මැලි කවනේ ආපු. Okay. Directly above or parallel to the reading. Or parallel to the readings. Parallel to the reading measurement marking on the ruler. Parallel to the marks. There is an error occurs. There is an error occurs, so there is an error known as parallax error. Okay. Remember that one. I won't pin it. I think you can. Okay. So then let's move to the next one. Now it's sufficient enough for the meter rule. කවුරුන්නේ නේද? Actually, the meter rule. Okay. Yeah, that's sufficient enough for the meter rule. So now let's move to the Vernier scale. We are not moving to the Vernier caliper yet. Before that, we need to identify the Vernier scale. Okay, Vernier scale. Because I think now it's okay. If you want more time, I mean, if you need more time, then tell me. I think now it's sufficient enough. Okay, so let's move to the next one. So I'm moving forward. Now we can, when you take that meter rule is a basic one. You know about meter rule. So when you take the other equipments like Vernier scale, Vernier caliper. I'm no need to write this one. No need to write Vernier caliper, traveling microscope, and there is another one known as. We are not using that one yet. That one is for what we call the optics, spectrometer. Spectrometer. There is another equipment known as spectrometer. So there is a method. There is a method that we are that there is a scale actually. There is another method or scale known as Vernier scale. So the equipment which the Vernier scale there are certain equipment which the Vernier scale is used. Okay, so Vernier caliper is one of the equipment which the Vernier scale is used. Okay, so I'm not going to write it now. We'll write it later. The concept is, first thing is you need to know about the Vernier scale. Why we need a Vernier scale? Now let's take, you need to measure something smaller than 1 millimeter. And our meter ruler is on the smallest measurement, the least measurement is the 1 millimeter. Now I need to measure something smaller than the 1 millimeter. How do you do that? How do you do that? Or sometimes the meter rule accuracy is not sufficient enough for us. The meter rule, let's talk about the accuracy later, but there is something known as fractional error, percentage error. We'll see that accuracy is not sufficient enough. Then you need to go for some accurate measurements. That 1 millimeter is not accurate, or that one is not accurate or sufficient enough. Accuracy is not sufficient enough. Then we need to go for some other equipments. So one of the basic, or one is the most commonly used method is Vernier scale. Vernier scale. Okay. So let's take that. Let's take now. If you want to measure something less than 1 millimeter, one of the best approach, one is another approach. Some student can suggest why we are not dividing the meter rule furthermore. 1 millimeter. So the next option is I need to measure, let's take 0.1 millimeter. 0.1 millimeter. Then can we do that? So I think you here I mark the meter ruler like this, but take your foot ruler. You can barely see the 1 millimeter division actually. You can see, but the distance between two division is again it's not clear that much. If you divide that one again to smaller divisions, you can't. You need to use a magnifying glass definitely. You need to use a microscope. Okay, so one student can suggest divide that meter rule again to 10,000 divisions, not 1,000, 10,000. Likewise, there are some suggestions, but not practically possible. Okay, so if you want to measure smaller measurements, so another practical approach is this Vernier scale. Pierre Vernier, I think he's a French mathematician, a French developer, French scientist. He developed Pierre Vernier, a French scientist. He developed this simple solution. I mean, for this problem, he developed a simple solution known as Vernier scale. Okay, so write down the heading Vernier scale. So there are equipment that this method is applied. One of the basic one is Vernier caliper. So before that, we need to understand what is this Vernier scale. So why we need the Vernier scale කියන එක. So write down that under the Vernier scale, if you want to measure something less than 1 millimeter, if you want to measure something less than 1 millimeter, if you want to measure something less than 1 millimeter with a certain accuracy, I mean, at least we need to have a certain accuracy. If we want to measure something less than 1 millimeter with a certain accuracy, if you want to measure something less than 1 millimeter with a certain accuracy, there is a necessity to have a different arrangement because we can't divide the meter rule into further division. It's not observable. We need to have a different arrangement. And Pierre Vernier and Pierre Vernier we need to have a different arrangement. And Pierre Vernier, I think yeah, Pierre Vernier, a French scientist. Okay, Pierre Vernier we need to have a several arrangement, and Pierre Vernier was able to come up with a simple solution and Pierre Vernier come up with a simple solution known as Vernier scale. Pierre Vernier was come up with a simple solution known as Vernier scale. Vernier scale. Okay, Pierre Vernier was able to come up with a simple solution known as Vernier scale. Okay, so there is a mass spectrometer. In chemistry, you are learning mass spectrometer. That one is a different one. That's a different one. That one is you can learn that one in physics also, in magnetics and electrostatics. Yeah, mainly magnetics. Yeah, because you know that when you take different types of materials, there are certain isotopes. You know that carbon C, it's 12. No, I can't remember this exact mass number, but there are different isotopes. So to identify different isotopes, you need to have a what we call a device. It's like a magnetic field. You know, you can say that you can see those things, but there is those things are you can learn in not in next year. Yeah, but let's see. But those things are based on magnetic fields. You can see when these particles are moving or accelerating in a system, then if those things are exposed to a magnetic field, they are bending. So with that radius, you can measure the mass of that. E over m ratio, you are taking E over m ratio is a constant, I think. that to find the E over M ratio, they use the mass spectrometer. That is a different one. We have another one, spectrometer for optical instruments to observe some. I'll show you that one since I discuss about the spectrometer, because that one its Vernier scale is again used, but that one is a circular Vernier scale. I'll show you the spectrometer. It's like nothing good up your 2027 batch. I mean, your senior batch also still don't know about this stuff because they are still doing mechanics. What is that? Spectrometer. So this is the spectrometer. So we are using this one to take certain optical practicals. You don't know if I don't want to explain that because I don't like to explain that one because you don't know about this stuff. To find the simple practical is we are using this one to find the prism angle, the angle of the prism, and the deflection minimum deviation angle. But finally you can measure the what we call refractive index of a prism, refractive index of the glass. So you can see here we can keep the prism on the table, and here there is a Vernier scale. You can see here Vernier. So Vernier scale on that equipment. This is the spectrometer. I'll show you the reading. Do you have the reading? Yeah, these are optical practicals. Those are very, you can enjoy it actually. මේ practical කියන්නේ super හරි. You can learn these things and you can get the hands-on experience definitely if you can go to the school. I mean, there might be some students who are doing practical. Who are doing private. Sorry, who are doing private, but doesn't matter. You can. We are teaching you. We are showing you the videos, and you can learn that from. You can learn from that videos. Doesn't matter. But if you can get, I mean, if you can go to school, definitely go to do the practical. Okay, මොනවා වුණත් class cut කරන්න එපා practical කරද්දී. Okay, I can't show you that one here. There is a small place to take the observations. So here you can see in this one there is a place to take the take the readings. You can learn that one later. That is the optical spectrometer. Okay, mass spectrometer පෙන්නන්නද ඔයගොල්ලෝ mass spectrometer එක? ඔයගොල්ලෝ දාපු හින්දා. I think these things new for you guys now. So yeah, let's see mass spectrometer. I told you that you can see it's like it's not that much simple device. You can take that as we are using magnets to bend the you can see here we can take there's electric field to obtain different isotopes. So here you can see there is a magnetic field to accelerate the system, and after that to bend we have a magnetic field, and after that you can detect the mass and the E over M ratio. Okay, you can learn that we are doing these things in physics also under the magnetics and the statics. Statics, I mean electrostatic field. Yeah. So then let's move to the Vernier caliper again. So we're not Vernier caliper, Vernier scale. It's 9, 10 ne. හරි ඔයගොල්ලන්ට විනාඩි 10ක් දෙන්න. විනාඩි 5ක් දෙන්න. Let's start at 9:15. I'll give 5-minute break before going to the Vernier caliper. Taggal washroom යන්න ඕන නම් ගිහිල්ලා එන්න. I also need to I need to also bring water. Yeah. Before going to, so now we are moving to the important thing. Up to now we discussed some basic things about the meter rule and some measurements. So now we are going to start a new equipment. So get fresh and enjoy, and you can enjoy definitely. So I can show you. I have some simulation for you to get it to learn these things. So here you can see this is the site. There are several sites. You can also these are not developed by myself. Okay, so but you can practice the Vernier caliper, Vernier scale using these simulations. So you can see I can move this one. Okay, so let's see how to use this equipment, and this is another good simulation, you can keep the object also there and you can take measurements. Let's see. Okay, see you after 5 minute break. Taggalen, gihilla. Okay, let's start. I forgot to bring that test tube. So let's see. So can you see this? Okay, pain a test tube. Yeah, because we need to take some measurements. I need to measure the diameter of the test tube balloon. This is a spring balance. This is also measuring equipment, but we are not using this much as a laboratory equipment. But you can use this one also to measure the mass or weight. I'll explain that one later. Okay. Everybody, now I think you guys are there. Okay, let's start. So now, I forgot to bring that with what we call test tube. Okay, this is the Vernier caliper. Yeah, let's move to the theory part first, and then I'll show you how to work on this one. Yeah, so let's define the basic Vernier scale. There is a basic one. So you can see this is the most basic and the common scale you can see on the see in the laboratory. Hari, ආසන්න ඉගෙන ගන්න. ආසන්න ඉගෙන ගන්න. So මෙතන කියන්නේ you can also work with a certain passionate about what you are doing. So then you can enjoy really what you are doing. I am doing this teaching for you hello students, and also I am doing teaching for university students. Okay, I'm university. I'm not a lecturer yet. I don't have a PhD yet, but let's see. Because I finished my BSc last year. I graduated December last year, December. Currently working as a instructor, simply a demonstrator, but in our university it's known as instructor. Okay, so we are doing practicals for young engineers in University of Maratua, and like that. Yeah, so passionate about, passionate what you are really like, and then you can enjoy what you are doing. And as a student, I think in this time the best important thing is to work hard. Okay, always work hard. I think still you are not getting to the mathematical questions, or when you are moving to the what we can say, when we are moving to the linear motion, you can see we are doing a lot of theories, and then it's very hard to memorize all this stuff. But if you can really enjoy these things, it's very easy to memorize, not the memorize, to get into your body. Simply, let's say now you are not memorizing the name of the friends. So let's say you have a friend, this automatically you can those things are getting to your mind. So always use that. Use the theories, use the principle, and then automatically you can get familiar with these stuff. So no need to apply extra effort to memorize. Automatically පුළුවන් වෙනවා. Okay, so now let's move to the scale. So now let's work on it. Then this is the basic one. So let's take the basic Vernier scale. Write down something like this. මෙහෙම ලියන්න. Star එකක් දාලා just write this one. Put a star. So this is the basic Vernier scale. So I'll explain the scale with this one. If 9 millimeter, if 9 millimeter or 1 millimeter within bracket දාගන්න. If 9 millimeter within bracket දාගන්න 9 division of 9 number of divisions yeah, if you can write 9 number of divisions in the main scale. You can see what is main scale. In the main scale, you can see what is the main scale later. So if 9 millimeter, 9 number of division, 9 number of divisions, by 9 number of 1 millimeter divisions. Okay, by just write that. You can 9 number of 1 millimeter divisions of in the main scale. Okay, 9 number of oh yeah, 9 number of 1 millimeter divisions. 9 number of 1 millimeter division in the main scale. That is a 9 millimeter. 1 millimeter into 9. If 9 millimeter, 9 number of 1 millimeter divisions in the main scale. In the main scale is divided into 10 equal into 10 equals divisions into 10 equal parts or division if 9 millimeter is divided into 9 millimeter is 9 number of, this is 9 number of 1 millimeter divisions in the main scale is divided into 10 equal divisions if 9 millimeter 9 number of millimeter division in the main scale is divided into 10 equal division, then the following Vernier main scale Vernier, then the following Vernier scale if 9 millimeter is divided into 10 equal divisions, then in the following Vernier scale or if 9 millimeter is divided into 10 equal divisions, then the following Vernier scale is මේ if කෑල්ල කපලා දාමුද මට මිස් කෑල්ලක් දාගෙන පොඩි අවුලක් වෙනවා. So typex that one, can we erase this? Just typex it, sorry for that. පොඩි මේ අවුලක් වුණා මගේ වචනවල. Okay. 9 millimeter, that means 9 number of 1 millimeter division in the main scale is divided into the 10 equal divisions. Then the following Vernier scale is developed. Just remove that one. If line can doesn't matter. Just remove that. If typex it, come on. I'm telling you typex it. Okay. 9 millimeter means 9 number of 1 millimeter division in the main scale is divided into 10 equal division. Then the following Vernier scale is developed. Okay, this is the following Vernier scale. Okay. So now you need to draw this one. Okay. Take the meter, your foot rule. We don't need a meter rule. Just take your foot rule. You need to draw this one to get the practice. Take your foot rule. You can draw a line. Okay. Then mark 9 millimeter divisions there. 9 millimeter. Oh yeah, you can take 10 millimeter. Doesn't matter. So mark 10 divisions on the main scale, or just mark something like this. 1. Sorry. So you can take So you can do something like this. Just mark this one as 0. Then with the equal sizes, just mark I think on the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is my 10 centimeter. 10 centimeter, 1 centimeter, 10 millimeter. So this mark this one as 0. Then 1, no need to mark 1, 2, 3. 0, 1, 2, 1, 2, 3, 4, 5. Let's mark 5, 6, 7, 8, 9, 10. This is 1 centimeter. So mark this one. So this one is known as your main scale. You can see this is the normal normal meter ruler. This is normal meter ruler. This one is you can draw continuously. I mean, no need to draw that. But this one is go up to not 100, like 15 centimeter, like that. This is normal main scale. You can say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just mark something like this. So then draw another scale below this one. Draw another scale below this one. And this is 0. And as I mentioned, 9 millimeter, that is 9 number of 1 millimeter division in the main scale. 1, 2, 3. So this is 1 division in the main scale. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. So as I mentioned, 9 millimeter means 9 number of 1 millimeter division in the main scale is divided into 10 equal division. So I need to divide this one. This is the 9 millimeter section. I need to divide this one to equal 10 divisions. You need to divide this one again to 10 equal divisions. And the thing also. You need to divide this one into 10 equal size divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Nandinidiya පොඩ්ඩක් මම shape එක කිව්වොත් you can keep a small difference there. So ඒක චුට්ටු චුට්ටු වැඩි කරන්න. මෙහෙම. වැඩි කරලා මෙන්න මේක මැද්දට ගන්න. So you can keep a small gap here. Then you can increase the gap little bit. So you can increase the gap 2 times, 3 times. So then keep that one on the middle, and then again, yeah, not that one. Keep this one at the middle. 1, 2, 3, 4, 5. You can start from a small difference at the beginning, then increase this one a little bit, and keep this one at the middle, and again reduce this gap. Then you can draw it clearly. Okay, draw this one. So this one is known as main scale. So this is the Vernier scale. So such this is what is the size of main scale? What is the size of? This is 1 millimeter. So what is the size of, or what is the length of the 1 millimeter? So what is the size of one scale of the main scale? What is the size of one division? What is the size of one division in the main scale? 1 millimeter. What is the size of one scale, or what is the size of not one scale, sorry. What is the size of one division in the main scale? What is the size of one division in the main scale? This is 1 millimeter. Because these are, you can see 1, 2, 3, 4. This is 5 millimeter. 5. I'll mark this one is millimeter. This is millimeter. 1 centimeter, but this one is 10 millimeter. I'll mark with millimeter. This is 5 millimeter. So this length is 10 millimeter. I'm choosing 9 of that. I'm choosing 9 of that. 9 such divisions, and again divided into 10 equal divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10th. Okay. So this is the main scale. This is a Vernier scale. So as I mentioned, 9 number of 1 minute division in the main scale is divided into 10 equal division. Then the foreign Vernier scale is developed. Okay. Okay. Harith. So now, before going to the other cases, tell me these things. Okay. Tell me the size of the main scale division. Size or length, simply size of a main scale division. Simply you can write main scale as ms. Very simple. So main scale or ms. ms dhoni name ms. Okay. Main scale, size of main scale equals, how do you get it? It's 1 millimeter. You can observe it. 1 millimeter. Then size, how do you find the size of Vernier scale? Size of a Vernier scale. Vernier scale, size of main scale division. Vernier scale division. Division is 1 millimeter. Then size of Vernier scale, or simply VS division. How do you find that? Tell me. I know that, but tell me. Okay. How do you find that one? So according to the definition, you can see, or simply you can, you are the guys who did O levels recently. O levels subject kiyate wala hatti bane 10 9 sorry. You guys did 10 subject in O levels. 10 කරපු ඕගොල්ලන්ගේ තුන මොකද්ද නේද? So there are only 3 subjects in A levels. 10ක් නෙමෙයි sorry 9. So there are 9 subjects in O levels. 9 ගේමක් නැත්තම් තුන මොකද්ද? නේද? හරි okay we see. Hurry, okay. How do you calculate then? So 9 such division divide again by 9 such division means 9 into 1 millimeter. So how do you calculate correctly? 1 millimeter into 9 divide by 10. Then 0.9 millimeter. Nice. Okay. 0.9. දෙයක් නෑ නේ මොනවද? 9 දාන්න තියෙන 10. රජුවටද කොස්සටද? එහෙම තමයි රෝස්ටර් කියන්නේ. රෝස්ටර් කවුද? So he is the person who develop, I mean who he's a Professor Rosa. So he was I think currently he also working on these papers, physics paper panel, yellow physics paper. Rosa, he's very famous because of that books. There are so many review books. Okay, you can also purchase that if you want to refer to take reviews. Those are in Sinhala mostly, but there is a separate book for MCQ only in English medium. Okay. So size of Vernier spelling හරද්දලා නේද? n එක දෙපාරක් ලියන්න. ඔගොල්ලෝ මගේ ඕන ලියන්න එපා. එහෙම ඩාම් වෙනවා ඩූම් වෙනවා. Vernier scale. Okay. Yeah. So then yeah, okay. So now what is the least count? So how do you take measurements from this one? දැන් ලස්සන වැඩක් කරනවා. I'm going to develop a animation. Okay, ඔන්න බලන්න animation එක වගේ. So this is the animation. Simple animation. I'm selecting those stuff. I think you can see it. I'll increase the size. So here you can see initially those two zeros, these two zeros are collinear. Those two zeros are collinear. Can you see that? Don't write coincide. Some students or some, I don't know, these things are change. I think when we are learning these things, when we were learning these things, they taught us, but still some of that students, they are using these terms. I don't know why, how they learn that. Coincide. Okay, don't use their coincide term. Sinhalin can sampādaka. අපි කරන කාලේ අපිට කිව්වා don't use that, but nowadays they are not giving marks for that. Coincide කොහෙද ඇහුනොත් එහෙම don't write that. Okay, so coincide means is overlap. In not Sinhala, there is a synonym. Let's say coincide means they are overlapping, but here the lines are not overlapped. Okay, overlap means just one reading or one line overlap the other one. There is no overlapping. Okay, so they are collinear. Collinear. So you can consider the two zeros are collinear first. The two zeros are collinear first. So now if I try to shift this one little bit, but animation na maruni. Okay, so if I try to move this one, shift the entire Vernier scale. So this is my Vernier scale, anything. So if I shift this one, you can see initially those two are collinear. So what is the minimum distance that I can shift this to make one of the I mean, you can see here all these lines are not collinear. Other lines, these things again collinear, that doesn't matter. But here all these lines are not collinear with the main scale. You can see here there is a gap. There is a gap. But now I would like to shift this one and tell me which one. So when I am shifting, what is the first instant that you can make one of that, I mean, one of that line collinear with the main scale. When I am shifting this one, what is the minimum distance? What is the minimum distance that I can shift, or that I can move until one of the Vernier scale collinear with the main scale? So I am not doing that, but tell me now. I can shift this one. I can shift the Vernier scale. So tell me what is the minimum distance that I can shift until one of that line get collinear with the main scale. So all the other things are not collinear yet. But what we can do, I can, so here remember that this is the first instant. I can shift little bit. Until one of that line collinear with the main scale. Okay. You can see now those things are collinear. So identify the concept. So this is the minimum distance that you can move until one of that line collinear with the main scale. Okay, got that? So I show you animation, perfect animation. Okay, so now you can see that there is difference. I mean, there is a gap between two zeros. Okay, so what is the gap between those two zeros? Tell me. So I need to find the gap between these two zeros. I need to find this gap between two zeros. Okay. So now just write that one. If the Vernier scale is shifted little bit, if the Vernier scale is shifted little bit, until one of that Vernier scale collinear with the main scale. Until one of that Vernier scale collinear with the main scale, comma. If the Vernier scale shift little bit, until the Vernier scale until the one of the division collinear with the main scale. Right there. If the Vernier scale shift little bit until the one of that division in the Vernier scale collinear with the main scale. Collinear. Okay. Got it? So then tell me, you can draw it again. Earlier you drew a different one. On this one, two zeros are collinear. But let draw this one only. Just draw this one. I'll mark it. Just draw only this one. Just draw this part. Just draw this part. If you want, I can draw it again. Making a couple of you can draw this one again. Okay, just draw this one again. This part. Then you can draw only this part. It's a very simple thing. Okay. I'll draw it again. Okay, just draw something like this. This is 0. This is 0. And there is a bit difference between two zeros now. And these two lines are collinear. But these two are not collinear yet. Okay. So what is the size of this is main scale and this is Vernier scale. So what is the size of the main scale division? 1 millimeter. What is the size of the Vernier scale division? 0.9 millimeter. Then what is the difference between two gaps? Here. The difference between the two zeros. The difference between two zeros. You can take that one as 0.1 millimeter. How do you do that? Size of the main scale division minus size of main scale division. So then it is 0.1 millimeter. Okay. The difference between the two zeros in the main scale and the Vernier scale. Very simple approach. So now this one is actually, you can say 0.1. So let's take, if you develop an equipment using this scale, okay, if you develop something using this scale, so let's move to that simulation. This one is I'll take this. Okay, so monkey. So now at the beginning you can see observe this one. So you can see this is the main scale. So then there are 9 millimeter, or we can say 9 such 1 millimeter division divided again into 10 divisions. So this is earlier when so you can see there is equipment. Not everything about that equipment. Here you can see there is this one is known as Vernier Caliper. So when these are known as external jaws, I'll give you the name later. These are known as external jaws. So you can see initially when those two contact, these two zeros are collinear. These two zeros are collinear. Okay. Now I need to measure something. That, and you need to keep that one in between. The jaws. Let's take. You need to keep that object in between the jaws, like this one. Make it on pen. You can keep one of whatever object you can keep there. Okay. So the difference. So you can see earlier these two contact. When those two contact, the two zeros are collinear. So when you place an object between those two jaws, these two zeros are moving. There is a distance now. So you can see these two zeros are move. I mean, there is a distance between those two zeros. So we can consider the distance between the external jaws equal to the distance between two zeros. The distance between two jaws equal to distance between the two zeros. So our goal is to measure the distance between the two zeros. So we can take here when there is no object, when there is no space, those two zeros are collinear. If you place an object in between those two jaws, there is a distance between two zeros. So if you can measure the distance between two zeros, that one is the gap here, and that is the size of the object. Okay, let's take now you are placing an object here. You can place an object. Where is it? So there was object here. Let refresh it. I know anything. So there is object here. So I need to measure the size of this object. So I can keep it in between those two. So then the size of this one can be measured using the distance between two zeros. Okay. හරිද? මේ හරින් තියාගමු පරිස්සමට. පොඩ්ඩකින් measurement එක වෙනස් වුණා. Here you can see it's not that basic one. මේක බලන්න. When you make this two, you can see අපි දන්න එක නෙවෙයි මේ තියෙන්නේ. හරි? This is a different one. I'll explain those things. You can see this scale is different. Scale is this, so you can select that one. This is the scale that I am discussing currently. This is the basic one. Okay. So now there are so many Vernier scales. So this is the basic one. So distance between two zeros is the final measurement. So then tell me what is the least count here? So I told you final goal is, how do we take the measurement using this Vernier caliper or Vernier scale? You can see there are two zeros here, main scale and the Vernier scale. So when you increasing the distance between the two zeros, you can take there is a space, there is a distance, so there is a gap between two zeros. Okay. So what is the minimum gap? That you can create a distance between two zeros? That is the least count. So means what is the least measurement? What is the minimum measurement that you can measure using this equipment? So what is the minimum measurement that you can measure using this equipment? That is the smallest gap. That is this. So you can see here now there is small. Oh, you can't see it. So you can see there is small gap between those two. So that is the smallest gap that you can create in between the jaws, and also you can see this is the smallest gap you can create between two zeros. And now if you place an object here, if you place an object here, that one also measurable. So then what is the smallest distance or smallest measurement that we can take using the Vernier caliper? 0.1. You know that I explained that the smallest measurement means the smallest distance that you can create, or small gap that you can create between the two zeros. is that when I'm shifting this one, when this one, when these two collinear, so here now you can see, here, there, now I think you can see there is small gap, and when let's say there is a small object, and now you can place that one in between the jaws, and you can take that reading. So the smallest measurement that you can take using this equipment is the minimum, the minimum gap between the zero. So the minimum gap you can create between two zeros when this one colline with the main scale, when this Vernier division collinear with the main scale. So then because of that, what is the least count? දැන් තේරෙනවනේ සීන් එක. මේ හොඳටම ඇඟට වදින්න කියනවා හරිය. So I know that after this class you can't do any equation based with this Vernier scale. So the difference between the two zeros 0.1 means, so this is the smallest distance that you can create between the two zeros. I saw that a lot of students are giving the answer. Because of that, the smallest distance that can be created between two zeros, between ketene and, so the short form of between is something like this: between electron, short form electron, between. When I'm writing, sometimes I'm using this stuff. Okay, between, short form of between, two zeros to measure something equals 0.1, known as its least count. The small distance that can be created between two zeros to measure something is 0. Because of that, the least count LC equals 0.1. So what is the way, or how do we find it least count of a Vernier caliper? What is the general equation? What is the general equation to find the least count of a Vernier scale? There is this short method. Let's learn that one later. So how do you find the least count of a Vernier caliper? So you can write least count as a heading. And what is the general equation? No need to write heading, just write equation here. So least count equals least count of Vernier caliper. Least count of Vernier caliper equals size of the main scale division minus size of the main scale division minus size of the Vernier scale division. Size of Vernier main scale division minus, if you want you can write MS. Size of the main scale division. So save the, okay, save that fuel of the pen. Size of the main scale division, size of the Vernier scale division. Okay, so this is general equation, or the long method, because there is short method. Okay, short method is still valid in A levels. Short method is not a short, it's not a what we called it's not actually short method. It's a standard method, but somehow short. Least count, size of the main scale division minus size of the Vernier scale division. So there are different types of Vernier scale. So there are different. So I told you a basic Vernier scale here. I show you the basic Vernier scale here. What is the basic Vernier scale? 9 millimeter, again 9 number of 1 milli division in the main scale is divided into 10 equal division. Then the following Vernier scale is dual. This is the this is the basic base version. So let's take different types of Vernier scales like that. So the question here, Q. Let's do a question. Let's do a question. Write down the least count of the following Vernier scale. Write down the least count of the following Vernier following different type of following Vernier scale. Doesn't matter. Write down the least count of the following Vernier scales. Write down the least count of the following linear scale. Write down the least count of the following Vernier scales. Okay. So first thing, first one, I'll show you in those variation in that simulation. So under that, first variation is, so basic variation, you know that basic variation is in the main scale is developed or constructed by 1 millimeter scales, 1 millimeter divisions, not scale. The main scale is divided by 1 millimeter scale, and then you are choosing 9 out of that, and then again divided into 10 Vernier scale divisions. That is the basic one. Okay, then you can move further. The main scale, the main scale, the main scale divided in millimeters. The main scale is divided. The main scale is divided in millimeters, in 1 millimeters. So you can see there are 1 millimeter divisions in millimeters, and the Vernier scale is made by dividing 19 such main scale, 19 such main scale divisions into 20 divisions. 20 divisions. 20 division. 90 milligram such main scale division in 20 division. Okay. Yeah. The main scale divided in millimeters, and Vernier scale is made by dividing 19 such main scale division into 20 divisions. Meaning step stick karan. Mame step stick karan. So first write down the size of the main scale. Or you can write down direct calculation, least count equal size of main scale division. What is that? 1 millimeter minus size of Vernier scale division. How do you find that? 1 millimeter, because sometimes you are not getting the answer if you are not following this way. So you can see least count is 1 millimeter minus size of the main scale minus, I will do the first calculation for you. Least count equals 1 millimeter minus such 1 millimeter into 19, 1 millimeter into 19, such 19, such main scale division again divided to 20 Vernier scale division. So this is the size of the Vernier scale division. This is the size of the Vernier scale division. Okay. So then you can write, if you take the common denominator, take the common denominator. You need to write that. Take the common denominator. I know that you guys are perfect in calculations, but do this one. So then you can take, if you take 20 minus, this is 19, so then we can get 1 millimeter divided by 20. Write this step. Okay, 20 minus 90, 1 millimeter by 20. So then you can take 0.05. 0.05. That is least count of the this one. Okay. So intermediate step short method, the short method is developed with this intermediate step. That's why I'm asking you this intermediate step. Okay. So you can see here this step in a pain. If you write that intermediate step, in this case, the intermediate step means 1 millimeter minus 1 millimeter. No need to write it again. 1 millimeter into 9 divided by 10. So then when you take common denominator, you can take 10. 10 minus 9 means 1 millimeter over 10. Then you can get 0.1 millimeter. This is the previous least count. This is the previous least count. The difference between the two zeros is the smallest gap you can ever create. No, not ever, you can create it. So the smallest gap you can create it between two zeros. This is 0.1 millimeter. This is the 0.05. This is the smallest measurement that you can do. What is awesome seeing 1 millimeter divided by 20. Here, 1 millimeter divided by 10. Again, let's write the main scale is divided in 1 millimeters and Vernier scale Vernier scale by dividing 49 such main scale into 50. At least 50කට බෙදලා. The main scale I can copy it නේ. මොකද්ද මම pen අපරාධ තීන්ත නැස්ති කරලා. You guys need to write. ලේසියෙන් කරන්න ස්මාර්ට් බෝඩ් එක කරන්නේ. ස්මාර්ට් පෙන් එක අපි. Okay. ඕගොල්ලන්ට ස්මාර්ට් වෙන්න බෑ. If you are using a tab, then you can. Okay. So here I'm just changing 19 to 49. බනින්න එපා හොඳේ. දැන් මොකෝ අපිනේ ලියන්න ඕන 49 into 50. Write down that one. Least count. Question number 3. ඔයගොල්ලෝ දන්නවා මොකද මම කරන්න කියලා. You know that what I am doing now. Okay. So 99 into 100. If you can write in this, if you can understand the concept, you whatever way write that one in short way. Product hitting your command, but write that correctly. So here is 49 divided by 50, 99 divided by 50. Now I'm changing that one a little bit. ඔයගොල්ලෝ බය නේද කොහෙද කොපි වෙන්නෙත් නෑ අප්පු. Okay. Okay. What is zero error? තාම ඉන්නනේ මේ යෝ zero error ගන්නකයි we didn't move to the Vernier caliper yet. Zero error is a error in the Vernier caliper. Okay, so you don't know yet. I'll teach you. බය වෙන්න එපා. ඔයගොල්ලෝ බයයිද මම උගන්වන්න නැති වෙයි කියලා. හරි. ඉන්න හදිසියක් නැහැ අපි හිමිසර යමු. So here I'm changing. Here is 1 millimeter. So here let's take there is a main scale. There is main scale. The size of the main scale division is now 0.5, not 1 millimeter. Again, I mean you know that 0. This is 1. This is 2. Again that one divided into half. It's readable, okay? 0, 0.5, 1, 1.5 like that. So you have 1 millimeter scale. You know that 0, 1, 2, 3 like that. 1 millimeter scale again divided to 2 parts. So it is 0.5. Okay, so then in this case always I'm selecting 1 millimeter, but it is 0.5 millimeter size of the main scale. And then let's take 9 such division divided into 10 divisions. This is fourth one. I think you can see the board name. It's not small, but you can. The letters are small. I'm giving you various type of what we call the Vernier scales. Okay, do this one. So here is 1 millimeter divided by 49 such division divided by 50. These are important things you need to notice. 1 millimeter division. The main scale is developed or divided in 1 millimeter divisions, and 1 scale by dividing 99 such division into 100 Vernier scale division. Let's do this one. So least count, as I mentioned, size of main scale is 1 millimeter. So such 1 millimeter divisions into 49, that is the that one again divided by 50. So you can take the common denominator here. So then that one becomes 50. So then 50 minus 49 is 1 millimeter. So answer is 0.02. I think you gave the answer. That's good. So then again for this one, please count. Main scale size is 1 millimeter minus 1 millimeter. Such 1 millimeter division, you are selecting 99 such 1 millimeter division and divide into 100. Then you can select 100 minus 99 is 1 millimeter divided by 100 means 0.01 millimeter. This one, tell me the answer for the fourth one. Fourth one only. Give me the answer for the fourth one only. Now give me the answer for the fourth one. Fourth one. හතරවෙනි උත්තරේ කියන්නේ. Fourth one. Fourth one. Okay, I'm getting answers. Good. Good. Lihan kan. Hi. So the main scale divided in 0.5 main scale, and then so you can tell me the answer. But hi. You can take SS and write it as a homework if you need more time. If you need more time, you can take a SS and keep the space to write down the thing. Just in your mind calculate. What is the size of main scale? So मैं पटलो करने पारे 0.5. गोड़ा काटे मैंने वरंदा करना. You are most of the guys you are doing this error. So you are taking that 9 divided by 10 ko 9 over 10 kilo. It's not 9 over 10. And that's why I told you to write this one. Okay. So here, how do you find the size of the main Vernier scale? 9 such main scale. 9 such kuvam mean me 0.5 into 9. Don't write just 9 over 10. Don't write just 9 over 10 because 9 such main scale. So size of the main scale is 0.5. So this is 0.5 into 9 over 10. That's why I told you to write this one also, because if you are just writing 49 over 50, then this one definitely you are just writing 9 over 10. I know that. So these things are in millimeters. 0.5 millimeter minus 0.5 such 0.5 into 9 divided by 10. So you can take again, if I take 0.5 out, if I take 0.5 out, then you can take 0.5 millimeter out. Again, you can take, this is 1 minus 9. That one is 0.5 millimeter. You can take 1 minus 9 over 10. If you take common denominator, you can 10 minus 9. Finally, 0.5 divided by 5 millimeter divided by 10. Then 0.05. Okay. For this one, so all these things I am writing with the millimeter. Okay. If someone uses centimeter, you can write 0.00. You can write 0.0002. Sorry, not 0.002. There are two zeros if you write in centimeters. But I'm familiar, I would like to write that one in millimeter, then it's easy for you guys also. Let's take this one as 0.1 centimeter. 1 centimeter divided by 100. So finally 0.001 in centimeter, but you use the correct unit. This is in millimeter. So again, in this one you can write 0.5 minus 0.5 into 49, I mean 0.5 millimeter minus 0.5 millimeter into 49 divided by 50. And again, when you take common denominator, I'm writing directly 0.5 divided by 50. So it becomes again 0.01. 0.01. ඉතින් බලන්න හරියට මම දැන් කවුරුන්ට පොඩි තව 0 එකක් ඇඩ්ලා තිබ්බා. 0.01 millimeter, but if you are using centimeter, then yes, 0.001 centimeter. Okay. So then the short method. මෙච්චර මේ දඟලන්න ඕනේ නැහැ. බලන්න හැමෝගෙම පොඩි pattern එකක්. Follow the pattern. You guys are excellent to follow the pattern. මොකක් හරි එක pattern එකක් දැක්කම වුණාම you are trying to repeat that. පොඩි කාලේ you know that there are IQ questions. There are certain images. After that image, what is the next one? Right. So here you can see there is a pattern 1 over 20. I told you this one also the same pattern is there. 1 over 10, 1 millimeter over 10, 1 millimeter over 20, 1 millimeter over 50, 1 millimeter over 100. Here 0.5 divided by 10, 50. What is that pattern? If you follow that pattern, always you are following a pattern. What is that pattern? Tell me. What is that pattern? What is in your numerator and what is in your denominator? When you follow that pattern, you can see there is a common pattern. What is in your denominator? Number of Vernier scale. Number of Vernier scale. No need to think about this 99. Number of Vernier scale 100. This 50 number of Vernier scale. 20 number of Vernier scale. Always this one consists of number of Vernier scale. This one size of the main scale. Size 1. So then you can realize you can make so that's why I gave you this set of questions to identify the pattern. So now you can get the least count, the short method. Short method is also applicable in essay or structure. It doesn't matter. You can use this one. I don't like to, but you can write another method, short method. Short means in size is short, but this one also is standard method. That previous one is long method. This one is a short method. Okay. So least count. So whatever is Vernier scale, you can get the least. Whatever means you can see whatever least Vernier scale. So there are circular Vernier scale. There are extended Vernier scale. There are so many Vernier scale. So then least count for whatever case, least count always equal size of the main scale division. Size of the main scale division divided by number of circular, sorry, not circular, number of Vernier scale division. Number of Vernier scale division. Okay. Size of the main scale division divided by number of Vernier scale division. I think. Okay, you can write. This is a standard method. Least count. Okay. Least count, size of main scale division divided number of Vernier scale division. Okay. Good. Sorry. So now that is the short method, and now you know that that is the development of the Vernier scale. That is the development of the Vernier scale. Okay. So now we can move to the Vernier caliper. We can move to the Vernier caliper. So now you know about the Vernier scale. So what is the simple method? So now Pierre Vernier developed a simple approach that there are two scale, main scale and the Vernier scale, and there are two zeros. So always remember that the term collinear, don't try that coincide when a I mean, now they are giving marks for the collinear, but previous syllabus, the old syllabus, they use the coincide term. Because of that, when you are doing past paper, you can see that term. But nowadays we are using collinear because coincide means they are overlapping. Overlapping, they are not overlapping, they are just collinear. Coincide name collinear. Okay, so then let's move to the Vernier caliper. Vernier caliper. Write down the heading Vernier caliper. So now you know the way to calculate the what we call the least count of a given Vernier scale. So this is the Vernier scale. So when you take Vernier scale, there are so many equipment like what are the equipments use this Vernier scale? අපි එකක් දාගමු ඕනේ. ඉතින් දැන් ලාග. The equipments the equipments which develop using the Vernier scale, the measuring equipment or the equipment which include equipments කියලා ගන්න නෑ equipment. There is no plural word for equipment. The equipment which includes the Vernier scale, Vernier caliper, Vernier caliper. Then traveling microscope. I told you there is another measuring equipment. Traveling, I think there is one L. Traveling microscope. And we are learning, this one is not used in this lesson, and we are not learning that one in this lesson, but we are learning in future now. So that because of that, let's learn that one. Let's write that one here. Spectrometer. We are learning that one in not near future when you are doing optics. That one has a circular Vernier scale. We'll learn circular Vernier scale also. And another equipment is there. I think you know about that. What we call that? You know, stroboscope. Maybe. Or money angle measure කරන්න එක. හරි. පාඩින් ඉඳන් ඉන්නේ you know that there are civil engineers or not civil engineers. There are some civil engineers also doing that, but there are some guys standing on roads and measuring the angles. They are measuring the angles. Okay. So that equipment one is known as I think stroboscope or what like that. Let's see whether I can find this name. Theodolite, theodolite, maybe theodolite. Yeah, theodolite. No need to write that. There is equipment known as theodolite. In that one also, to measure the angle, they are using circular Vernier scale. I'm not giving right now because we are learning circular scale separately. Circular Vernier scale. Okay. So then now let's move to the official. Now we are moving to the Vernier scale. Vernier caliper. Now you know about the what we call the scale. So this one is the Vernier caliper. How did the maybe innocent? Okay, I'll give you a close up. මගේ මූණත් ලොකුට පෙනෙයි ගණන් ගන්න එපා. හරි. Okay. හොඳට පේනවනේ ලස්සනට පේනවනේ. ගොඩාක් පැක්ලිය පේනවනේ. සුපිරියට පේනවනේ. පොඩ්ඩක් ඉන්න අපි light down. Okay. ඔන්න පේන්න ගන්නවා. හරි. මේ don't think about the scale because this this one has a different scale. I'll explain that one later. Extended Vernier scale. Extended Vernier, but I'll explain that one later. That one is known as extended Vernier scale. So don't take the measurements here. I'm not trying to take measurements using this one. I'll use a simulation, but this one is the equipment. May I focus karo? Okay. I can't see your chat. So if you need a sudden answer, wait, because now I'm a little bit away from that my computer. Okay, so this is my Vernier caliper. I couldn't find out that no standard laboratory one. Laboratory one means that first thing we discussed 1 millimeter division, 9 such 1 millimeter divided in 10. That one is the normal regular one you can see in your laboratory. Okay, so you can see mommy and so how do we so when you take your palm, when you take your hand, normally you can keep your thumb. So you what the so you can see this band I know those. Okay, so now you can see this is the right way to hold the Vernier scale. You can keep your thumb to this rotating it, but this one is not rotatable. Earlier days, there are some rotating wheels actually. So what we can do, you can rotate this one and then you can move this. So there is another screw here. There is another screw here. You can see. Here is screw vertical. So you can release that screw first, and then you can shift the slide. අපි කියන එකට චලන හනුව චලනය කරන්න පුළුවන් චලහනුව movable part. So then this one is fixed part. This one is fixed part. You can't move this one, but this one can be slide. So when you slide, you can see what are the parts there. So follow the parts. You can see these jaws known as external jaws. Anything last one? External jaws. Okay, so these things are known as external jaws. What are those? These things are internal jaws. Okay, so then this one is the screw that we can lock the sliding gadget or sliding part. We need that one. I'll explain. So this one is we can say this is rotating wheel, but actually this one is not rotating now. And you can keep the finger here, and then after releasing this one, you can move. අමුතු සීන් එකක් වෙනවා. මෙහෙම rotate කරන්නේ තව ඔයගොල්ලෝ පේන්නේ නැහැ. මෙතන බලන්න. අමුතු දැන් මෙතන පේන්නේ නැහැ. ඔන්න now හැංගිලා ඉන්නේ. You can see now there is nothing here. But when I slide, ඉන්න බෝලේ අමුතු එක්කෙනෙක් එනවා. And you can see this one known as depth නෙමෙයි මැරෙනව නෙමෙයි depth probe. Depth ගැඹුර මයින කවුද? Depth probe. Okay, එන්න මෙයා. Depth probe. You can see if you take the other side, and if you take the other side, you can see when I'm sliding here, that part is also moving with the sliding one, the slider. Okay, so that is the back side of the Vernier caliper. So let's come to the front side. So now what are the, so I'm not going to write these things in your book. So why we need these external jaws? So these things are known as external jaws. So these things are internal jaws. External jaws, internal jaws. These things are known as external jaws, internal jaws. Okay, jaws, Jaws, jaws. External, internal, depth probe. You can see this is the Vernier. This is the Vernier caliper, and this is the sliding movable part. English sliding part. Let's see. Let's check whether there is English name for that. I can't remember. I can achala hanuwa kiya. In the calendar. Let's see whether there is a English name for that, because I'm not sure about it. Maybe, definitely. You can see what we call the syllabus or resource book. There are resource book freely available in the internet. Yeah, it's defined as movable mechanism, movable part. Known in the exam, they are not asking what is this. So this is the fixed part. This is the fixed part. This can't be moved. I mean, you can't move this side. This is just sliding on the fixed one. So here, what are the usages? So how do we use this one? Why we need such different jaws? So the external jaws are normally used for what? To measure external diameters. So I'll show you. මොකක්ද අපි ගන්න? බලමු මොනවද තියෙනවද කියලා messages. Sharp, yeah. Those are sharp. I have a plastic one also. මට ගෙන්නව තුන අපරාධ. අමතකුණා. I have that in my room. Okay. So this is the external jaw. Yeah, let's see in the next week. I'll bring that one also. Because that one is as the second Vernier type, second Vernier scale type, 19 division divided by 20. That one is there in that Vernier scale. This is extended one. This is still, I didn't discuss this part, but let's discuss the way that we are using the Vernier, caliper to take the measurements, and using the animation. I'll show you how do we take the reading. So I'm taking a test tube. Okay, now it is focused. This is a test tube. So I need to measure the external diameter of this one. External diameter. Can we figure out the radius directly? No, we can't. Radius, you can't find radius. So I need to measure the diameter. What we can do, you can keep your external jaws in between the okay. So yellow the pen. Okay. මාවත් පේනවනේ වැඩි. බෑ කොණ්ඩේ පේන. හරි. This is okay නේ. Okay. So and remember that so you can see here there is a sharp edge, as one of your friends said. This one has sharp edge. Normally you need to place your object in between those flat edges. You can see there are flat edges here. In the internal jaws also you can see there's a flat surface. Always you need to keep your object in between those two jaws. I will explain why what are the other ways, but always remember that you can't use I'll explain that concept. I mean, always you need to keep your object in between those two jaws. I don't know තියන්න ලස්සනට බලන්න මම තියලා තියෙනවානේ. ඇතුලෙන් බලන්න ඇතුලෙන් බැලුවට පේන්නේ නැහැ. It's very hard. I'll take this side. ඒකට තව උදව්වට කෙනෙක් ගන්න වෙනවා වගේ ඊළඟ දවස්වලට. Okay. So you can see here I kept this test tube in between the jaws, and then after keeping that one in between the jaws you need to use this locking mechanism. So normally what we can do, you can keep the object in between the jaws, and then ඒක දැන් කොහොමද ඒක කරන්නේ මම? හරි, I'll do it. Yeah, I need to show it to you. So you can keep මෙහෙම press කරන් දැන් මට ඒක කරන්න විදිහක් ඔයගොල්ලෝ පේන් කරනවා නම් හරි මෙන්න මෙහෙම බෑ පැන්න පොඩ්ඩක් ඩාන් වෙනවා ඩූම් වෙනවා. So you can keep this. That's the way to take the reading. Okay, I think you can get the idea. You can keep the object in between the jaws, and okay, you can keep the object in between the jaws, and then you can lock the screw. Then මෙහෙම ගන්න එළියට ඒක is not correct. Keep the object in between the jaws, and then while it is inside the jaw, I mean between jaws, rotate the locking mechanism. I'm locking it. Unlock kara. Yeah, now it's locked. Now you can take this one out. I lock that. Okay. Mangsulangin in locker. I use my pink finger to rotate that. So then now it is locked. So then you can remove this one. You can take this one out. That's the standard way to use the Vernier caliper. First thing, you can keep the object. So I need to measure the external diameter of this test tube. I can keep the object in between the Vernier caliper, and then you can bring it closer, and now it is contact. I can feel it. It's not movable now. Then you can rotate this. You can rotate this locking mechanism. I'm rotating it. Okay, so now I lock it, lock kara. I lock that. So then now you can take it out. So now you can, I'll show you the reading, but don't take this one first because I'll show you there is a difference between two zeros. Okay, so you can see this is the main scale 0. This is the main scale 0. I mean, you can no need to use this one. This is in inches. This one is in inches. So no need to take that one. So here, this one is in millimeter. You can see this is in millimeter. So you can see this one is millimeter. So this is a Vernier scale. So this is extended Vernier scale. No need to go for, I mean, I'll explain that one later. So because most of the industrial Vernier calipers are made of this extended Vernier scale. So you can see there is a difference between two zeros. There is a difference between two zeros. So you can see the zero is not exactly on a scale. You can see this zero is not exactly collinear with the main scale. So you remember, this is not the, you don't need to take the edge. So we should not get the reading of the edge. Okay, edge එක නෙමෙයි ගන්න ඕන. You should not get the edge. You need to take the reading of the zero. You can see my nail. That one is the zero reading. So take the so when you are taking the reading, I'll show you the way to take the reading also here. First thing is you need to take the main scale reading. You need to take the main scale reading. Main scale reading means where your zero locates. So here you can see your zero is located in between 14 and 15. You can millimeter. In millimeter, it's in between 14 and 15. So that means your reading should be 14 point something. 14 point something. Okay, so here, what is order? Okay, I'll explain it again. So you can keep the object in between the what we call this external jaws, and then you can use this lock mechanism to lock, and you can remove the object and then get closer. I mean, you can take that one closer to your eye, then take the position of the zero. Take the position of the zero. So you can see this is my main scale. This is my main scale in millimeter. So what is the millimeter scale closest one? Oh, the zero is located in between 14 and 15, means 14 point something. Less than 15, greater than 14 means 14 point something. That something can be identified using this Vernier scale. Using this Vernier scale. I will explain that one using simulation. Okay, did you get that one? Good. So here, one of your friend asked what is zero error. So how do you find the zero? I'll explain that one also now. So here, when you release this one, and if you bring these two external jaws closer, if you bring these external jaws closer, so when you bring those external jaws closer, you can see here the two zeros are collinear. The two zeros are collinear when the external jaws contact. The internal jaws ගෑවිලා තියෙන්නේ නැහැ. ඒක ගෑවෙන්නේ නැහැ. ඒක ඔකුන් පේන්නේ නැහැ. ඒක ගෑවෙන්නේ නැහැ කියලා. හරහට ගිහින් තියෙන. There is a you can see when I am taking it, they are moving like this. So you can't contact those two. ගෑවෙන්නේ නැහැ. ඒක හිර වෙන්නේ නැහැ. හරි. You can see when I am taking it out, they are moving like this. There is a gap between the two jaws. Okay. Can you see it? So they are in different two planes. This one is one plane, this is another plane, because they are passing each other. So those two are in different planes. So you can't contact these two. They are in different two planes, but these two, they are in the same plane. They are in the same plane. Okay. So now when you contact the external jaws, because you can't write the internal, you can't contact the internal, they are in different two planes. Now you can see it. But when you take the external jaws, they are on the same plane. So when I am increasing, when I close and when I contact those two, the zeros are collinear. But let's take, if you are making those two closer, still let's take there is error, there is a reading here. Let's take you are trying, this is a brand new one, because of that there is no error. but you are trying to make that closer. You contact and you are trying to contact these two, but still these two are not collinear. If those two are not collinear, then there is a zero error. We'll do that one also. If those are not collinear, that one is known as zero error. If those two are contact, but here this one is a new one, so there is no error. I'll explain why the types of zero errors. There are positive zero error, negative zero error. Then how do you correct that? Yeah, so that's about the external jaws. So now you know how to take the measurement, or you can take external diameter of this test tube using that external jaws. Okay, එහෙම ගන්න පුළුවන්. හොඳට පේනවනේ අද අපි ස්ටුඩියෝ එක හොඳයි නේ. අපි කියන්නේ මගේ. හරි. Okay. So then this one is the internal jaws. So let's see how do we use the internal jaws. So then this is the test tube, and again I need to measure the internal diameter. Let's see whether you have problems with this. ප්‍රශ්න? Do you have question? Okay, no questions yet. ඔන්න ආපහු ළඟට ආවා. So these are internal jaws. So now I need to measure the internal diameter. Anything? පේනවනේ? Okay. So then what we can do, again I can keep those two closer. මතුරුල දැම්මා. ඔන්න add කරා. හරි, I can put these slide jaws into the test tube, and then I can try to increase the distance, and now you can't move that one now. That means those two contact. Then I can lock the you can lock the mechanism. Now you can take this one out. Okay, now it's okay. Yeah, let's keep it like that. Okay, because of the sharpness of that no, take it out. You can take it out. So now we can take the reading. So now the distance between those two, I think here when those two contact, there is no difference, there is no distance between those two. You can see here. You can see when we take when you close these two, there is no distance between the internal jaws also. So now what we can do, we can keep we can insert this one, and then you can contact internally. You can contact internally, and then you can lock the mechanism, and then take it out. Now take the reading. So you can see, now take the main scale reading first. So this one is known as main scale reading. So this one is 0, 1, this is 10 millimeter. I'll take it closer to you. You can see here is 1, 11, 12, 12 point something. 12 point something. Again, it's in between 12 and 13. That means 12 point something. Okay. So that's something you need to observe through this one. So I'll explain that one a little bit. So so don't take this reading, but let's try to figure out the collinear division. Collinear division can we identify collinear division in this one? So there are scales in the Vernier scale. Let's I think it's 5. So you can see, what's your opinion? What is the 5 much better, ne? Or the division next to 5 is also much better. Maybe this one in between 5 and 6, this division. So don't read this one. Don't read this one. I mean, don't read 0, 1, 2, 3. Just neglect that one. Calculate. I mean, count the number. This is 1, 2. This one 0. This middle one is 1. These are divisions. මේ number එක ගණන් ගන්න නැතුව don't take this number. Take 0 1 2 3 4 5 6 7 8 9 10 11. I think 11th division is collinear with the main scale. 11th or 10th. What's your opinion? Maybe, yeah, 10 is much better, no? 10 means fifth one. That one is collinear. So likewise, that is the collinear division of the main scale. So then I will explain how to get the final reading. So main scale division plus collinear division into least count. So this one is the least count of this measurement. That one also given here. But I will tell you the way to get the final measurement. But you need to figure out we need to figure out the main scale reading as well as the Vernier scale reading, like that. I'm just giving you the idea how to get the main scale closer reading. That one here it is. You can see it is in between 12 and 13. You need to take 12 point something. That point something you need to identify using the Vernier scale. So then you need to identify the collinear division in the Vernier scale with the main scale. The collinear division in the Vernier scale with the main scale. I think this one is 5. 5 can 10 division. Okay, don't read that number. It's 10th division. There are 10 divisions up to that point. Okay, that's about the way to get the divisions. Finally, I will explain how to get the final reading. So now the other side. So you can see this is known as depth probe. Okay. So let's take the other side. When the external jaws are contact, when the external jaws are contact, you can see this one is fully inside. And this one is fully inside. එළියට කැරලා කැවිලවත් නැහැ. හරි. ඇතුළට නැහැ ගාන්ට් එක. That one on the surface. That one on the surface ගාන්ට් ඉන්නවා. When it is fully closed. So now, as the name suggests, we are using this one to measure depth of a given what we called this one is used to measure the depth of a given object. So let's take there is a beaker here. පොඩි බඩු වගේක් තියෙනවා අරන් ආවා to take measurements. So I can take the measurement of this one also, diameter. I can measure the diameter of this one like this, external diameter. You can keep that object in between the jaws and then measure the external diameter. If you want to measure internal diameter, you can also do that using the internal jaws. Okay. Then if you want to measure the depth, here, then what we can do? So we can keep. So this is the Vernier caliper. So you can see this is the edge of the Vernier caliper. This is the edge of the Vernier caliper. This is the edge of the Vernier caliper. So I told you that at the beginning, the depth probe is located at the edge of the Vernier caliper. The depth probe is located at the edge of the Vernier caliper. So you can consider the edge of the Vernier caliper is the zero location. Edge of the Vernier caliper. So this one is the zero initial reading. You can consider, since the depth probe is located at the edge, you can consider this is the zero reading. This is zero. So edge of the Vernier caliper can be considered zero location. So relative to the 0 point, what we can do now, you can consider edge of the Vernier caliper is the 0 position. Okay. Now my goal is to measure the depth. So I can keep the edge on the beaker, brim of the beaker. So because Can you see it now? Okay, so this is the beaker, so I can keep the edge of the beaker, so edge of the beaker, brim of the beaker on the edge of the vernier caliper, and then move and move the depth probe until this one contact the bottom surface. Okay, so more practical gani one කොහෙවත් නැහැ මේ හොඳේ. You can see in our time we didn't get this kind of practicals. You can see here this one Anuradha කොහොමද කරන්න කියලා හෙට ගිහිල්ලා කට්ටිය maybe he also doing these practicals in class, and you can also enjoy. So then here you can consider this is the zero location. This is zero location. Right? So then I can insert this one. So this one contact. You can insert until this one contact. So now the movement of the depth probe is the depth here. So as I mentioned, you can. I told you that. I told you that this side. This one. I told you that this is the zero. This is the zero, and relative to zero, this one gives a the depth probe gives a depth. This one. Okay. Product dang, doom, okay. So you can measure depth here. One lesson. So this is the zero position. Then according to zero position, you can measure the movement of the depth probe. The movement of the depth probe is the height, the depth of the beaker. So the movement of the depth probe is the movement of the two zeros. Movement of two zeros. Because I told you when you contact the external jaws, this is the zero location, and at that point, this also at the edge of the vernier caliper. And so that is the zero position. And now what we can do? So you are taking the movement of the depth probe relative to the edge of the caliper. This is the edge of the caliper. This is the edge of you are taking the measurement of the depth probe relative to the edge of the caliper. So that means the movement of the depth probe is the height or the depth, and you can take that difference directly from the difference between two zeros. Okay, so here it is. What the reading? Can you see it? It's 70 something. No need to take exact reading, just take the main scale reading. It's 74 something, 74 point something. So then you need to take the vernier scale reading also. Okay, I think. Okay. Meeting අපි studio. Okay. Okay, now you can see the board. So do you have any question? So you can practice this one in your what we call laboratory, school laboratory. Common. So okay, so now you can take that measurements. So now what we can do, we need to practice the way to get the reading. So as I mentioned, first thing is you need to take the main scale reading. Main scale reading is the closest main scale. Okay, so then second one is you need to take the collinear vernier scale division. And then after that there is a small calculation. Finally you can get the final answer. Yeah. So now I think it's better to do that one in the next week, Ned. So I think you if you want මං පොඩි කාලේ මගේ පොතක් පෙන්නන්න. හිතන මගේ පොතක් තියෙනවා. I brought this one to show you my dedication. ඔක්කො නෑ නැත්තම් මං නිකම් පෙන්නනවා. හරි. වැඩි පේන්නේ නෑනේ. So no need. But if you want, you can draw something like this. Make it තියෙන සිංහලෙන්. හරි ගණන් ගන්න එපා. So this is my Vernier caliper. When I was a student, I drew a Vernier caliper here. Okay, so I marked all the relevant parts. So you can draw. So this is depth probe. This is the external. This is external jaws. This is internal jaws, and this is the what we call screw, and this is the Vernier scale. This is the main scale. Okay, like that. You can draw if you want that one in your book to make that complete. So then we can move to the Vernier scale, how to take the readings like that. And I'll show you the other equipment. So this is my micrometer screw gauge. Light off කරන්න. Okay. ඔයගොල්ලන්ට මේක මේ වෙලා නෑ. This is my micrometer screw gauge. මම ආර්ට් නෙමෙයි කරේ හරි මම පොඩ්ඩක් මම ස්ටෙමික් කරේ. So draw that one if you need. So this one, this is the spirometer, and finally this one is the traveling microscope. Traveling microscope, including all the parts. Yeah. So that's about the note. If you want, you can. I think now you know the Vernier caliper, so you can take a video, or not video, a photo. You can take a photo from Google, and here there are sites. So this one is a good Vernier caliper. You can see, you can change the zero error. You can change the number of counts in the main scale division, Vernier scale division, zero error. So like that. This is also a good simulator. I'll explain this stuff in the next week, because now it is 11. So you can see here in this site, the screw gauge is also there. This is the micrometer screw gauge, the second instrument that we are learning. So this is the Vernier caliper. So there is another one, micrometer screw, my spirometer. Okay. Yeah. So that's about the. My result. I was the 22nd in Colombo district. My school is Ananda College. Okay. I did A-levels in 2019. I am the 22nd. Island rank 100. Okay. So how you see here? District. Okay. So we'll study these things later. Later means in the next week. But next week, do you need a holiday? 15th, the Wednesday. So that is a New Year week. I think you don't need a holiday. Message. I think this is online class. Do you need that? If you want, you can draw that. But doesn't matter again. If you are get familiar with if you are getting familiar with the terms, then it's okay. If you are familiar with if you are getting familiar with this equipment, then no need to draw it, because I think in your tute the parts are marked. The equipment is there. Then the what we called the equipment is there. I think the parts, yeah, there's the what we call that the parts are also marked. Yeah, okay. So remember that. So today I discuss the basic about the main Vernier scale, and then we discuss about the what we call the what we call the meter ruler concept, meter ruler. Those things are also very important. Meter ruler, how to use the proper, I mean, how do we use the meter rule to take the proper measurements. So then you need the meter rules also, because you can see here this equipment, the maximum reading normally you can take the laboratory equipment, the maximum reading is 15 centimeter. 15 centimeter. Okay, the maximum reading that you can take from this one is 15 centimeter. But there are some other one. Mechanical engineering කෙනෙක් එයා ගාව තියෙනවා මේක ලොකු එකක්. මං කිව්වේ පොඩි කාලේ මට ඒ කාලේ මතකයි. I learned this equipment when I was a kid, but at those time I couldn't understand this one. මට බැන්නත් එක දවසක් මේක ගන්න ගිහලා. So difference between two zeros. Earlier I identified the difference between those two. I mean, I calculate the difference between the edge of the, I try to identify difference between the edge, not the two zeros. Hi, not the difference between two zeros. I'm zero. Okay, so now you can see the two zeros are collinear. When I was a kid, I tried to take the measurement between the edge of the Vernier caliper and the zero. I mean the main scale zero. Finally, I realized the distance between the two zeros is the measurement. I'm okay, එහෙමනේ තාත්තලෙන් ගෙනන්න ගියා. පොඩ්ඩක් කියලා තේරුම් නැත්නම් බයින්. හරි. Okay. So I saw that there are so many Vernier caliper ranges. මේ මෙච්චර විදිහට ලොකු ඒවාක් තියෙනවා හරි. Vernier caliper around this much of Vernier calipers. මේ size එකේ මෙච්චර දිග ඒවා තියෙනවා. Not that much big, but the length is maybe around 50 centimeter. But the laboratory equipments, we are dealing with laboratory equipments. Laboratory equipments, this is the standard size of the laboratory equipment. So then this is 50 centimeter. 15 centimeter. 15 centimeter. Okay, so this is 15 centimeter. So with that, you can go up to, you can measure up to 15. But let's take, if you want to take more than that, then you need to go for meter ruler. Definitely, you need to go for meter ruler. Yeah. Okay, so I'll stop at this point. So next week we are we can finish the Vernier caliper. We can learn the way to take the measurement using Vernier caliper, and then we can move to micrometer screw gauge also. Let's see. But before going to micrometer screw gauge, I would like to discuss some errors, because now you have the, I mean, you know the equipment. You know some of the equipment like meter ruler and the Vernier caliper. So before going to the micrometer screw gauge, I will explain different types of errors, not the zero errors. There are some other errors and error calculations, fractional error, percentage error. So why we need to go for another equipment without using this one, why we need to go for another equipment like micrometer screw gauge or spirometer. There are some reasons. So to explain those things, we need the error calculation. So we need errors, simply fractional error, percentage error, like that. So because of that, next week I'm finishing this Vernier caliper. So all the errors, zero errors, how do we correct that, like that kind of information I will provide. And then yeah, and then percentage error, those things also. So finally we can move to the micrometer scale. Let's see, I think next week we maybe, but not sure. Yeah, so that's about the Vernier caliper. So today I showed you the way to use this one to get the readings, and then that's the part, that's the basic introduction about the Vernier caliper parts. And remember that I will tell you the way to get the reading use how to get the exact reading using this one. I didn't tell you today. Okay, so I'll stop at this point. Do you have any questions? Do you have any questions? I think this video you will get this video on your Telegram. If you need, you can send this one to your friends. Okay, doesn't matter. You can take that link and share this one with your friends. Ask them to join with us if they are okay with online, because we don't have a physical class yet. But I think online is also you can enjoy, because you know that we did quite a good practical session today. I show you my webcam there is a screen. I check the footage with that screen, so that's thing went well. Okay, so you can share that one with your friends and ask you can ask them to come to participate to this physics online platform with the AP education. So AP physics, and yeah, that's about the today's class. And probably you will get a paper after the April, I mean after the new year, and not April, after the new year in this month. I will discuss that one also, because that one doesn't take that much time. Yeah, that's about that paper. Okay then see you on the next day, and happy new year. And also work well. So this week you don't get that much homework. So today we did practical. You are not getting homework here, so you can practice a dimension and the units. And also, if you want, you can draw the Vernier caliper on your book. Otherwise, not needed. At least get familiar with the terms. That's enough. Yeah. So I'll stop at this point. Then see you. Bye. Good night.